Morning, everyone. So if you have messages for me, just go ahead and put them in the Slack channel. And basically, I'm going to give you a little tour of what we're going to do today. Let me go to the GitHub. So this GitHub page is pretty much the layout for how the day is going to go. We're going to start with a quick preview. We're going to spend a little bit of time reviewing Swift, just so that we're all on the same page, get our minds warmed up. And then we're going to jump into some more detail about SwiftUI. And then we're going to dive deep into state management and come back around how we're going to use Combine along with SwiftUI. So the cadence for today is going to be basically a set of slides and then a set of playgrounds followed by a break. And we're going to do that throughout the day. And I'm hoping that around 1:30, 2 o'clock will be close to where everything is explained, and we'll go through the project. And the project will be done in a way where I'm going to explain how the project is set up, and then I'm probably going to go onto Slack and just answer questions and let you guys just work on the project at your own pace. So let's start with just a little background on Swift, SwiftUI, and why it's important. Now, as I'm doing this first set of slides, what would be good is if everybody could go over to your XCode, and you have to be using some version of XCode that is going to be able to run iOS 14. Oh, someone's saying the slides on Google don't seem to have images. Let me see. Might be just loading slowly. So hopefully that will be taken care of, because yeah, I've presented these slides before, and I think they're okay. But we'll see. Check back. Okay, cool. So I have to say a couple warnings before I actually get into the Xcode and all that. One, we're having severe weather here, and PG&E is threatening to cut power. So if I drop out, you know what happened. If our internet goes out or if power goes out, this might be a short seminar, but hopefully everything will work out. And the other thing is, on the Slack channel, I see people are answering questions, and I really appreciate that, because I'm not going to be able to put a lot of effort into the Slack channels. I'm going to be explaining a lot of things. The last time I presented, I gave a talk on Compose on the Android platform. And to my amazement, I was thrilled, but one of the main architects of the Compose team from Google was actually in the Slack channel answering questions for people about how Compose is built. And that made my job a lot better and a lot easier. So definitely please answer each other's questions on the Slack channel as we go forward. So with all that, while I'm doing the first set of slides, what I would like you to do is come over to Xcode, go to source control, go to clone, and then what you're going to do is you're going to go over to the GitHub repo, click this clone button, copy it, paste it into this window, and then clone it. That way you're going to have all the code that we're going to go through today. And this is really important, because I'm going to try to stay out of the slides as much as possible and stay inside of the code as much as possible. So let's get through the slides really quickly. So why SwiftUI? See if I can get a presentation. Okay, very nice. We have a lot to be grateful for what iOS has already done for us, because the very first Android phones that were coming out, they're actually targeting the BlackBerry phone. Until the iOS phone came out, there was really nothing like it. And people were actually building, I think, the wrong answer. And there's been a lot of firsts in iOS. It's really the innovative platform. And we actually build for iOS before we build for Android because of the innovation. We have a lot to thank the Clang compiler for, because what the Clang compiler allows us to do is take a lot of different languages on the front end and generate kind of the same code on the back end. When I saw the Clang compiler actually put out a posting saying, wow, this means that there might be a second language on the iOS platform, and everyone kind of laughed at it. But, you know, surprise, surprise, because of the Clang compiler, we actually did get an opportunity to, oh, sorry, someone has a question about, so where you get the slides and the repo is if you go to the main page for the i360, and then you click on the information. When you click on this link right here, it's going to get send you to the GitHub repo. And someone also linked it. Excellent. Thanks. So, all right. Yay. So we have a lot to be thankful for because of the Clang compiler. And since Swift is open source and it has been around from the, Git has been around from the very beginning, you can actually go watch the creation of the entire language. And for me personally, I teach a lot of different languages, and trying to teach Objective-C and then coming over to Java and Kotlin, Python, Ruby, it was really disconcerting to the students because they had to make this huge mental shift from Objective-C to other languages. And now, because of how close Android Jetpack Compose is to SwiftUI, it's very, very easy for us to make this kind of mental model between the two platforms. And by, you know, I spent a lot of time writing Objective-C code and working in UIKit. So I have a lot of fond memories of them, but I think that it's really time for us to move into declarative programming, where we're going to be able to basically just tell the system what we want, and it's going to produce it for us. So if I say menu, if I'm on a Mac, it's a pull down menu. If I'm on an iOS device, it's going to give me tabs on the bottom. And then if I'm on a watch, it's going to be the crown. And this is going to allow me to build my applications much faster and a higher quality with less mental strain on me. So I think it's really important for us to start moving to a declarative way of programming. Also, what I've noticed is with this new declarative UI, it's much easier for me to explain to people, to new students, how to build. There were a lot of steps to go through to build an iOS app before, and now with Combine and SwiftUI, it's much easier to teach and much easier for the students to grasp. And also, when I'm transferring knowledge from Android to iOS and iOS to Android, because Kotlin and Swift have a lot of the same language features, it makes it quite easy for me to work in. In fact, I was one of the very first people to be able to post on how to build with Android Compose and SwiftUI because the mental models are so similar. Now, one of the things that we really enjoy about SwiftUI is because there is no controller, it just makes it a lot faster for us to be able to develop. And if you're wondering about my personal development, I build with this concept of design sprints. And I provide this link here so you guys can go read about it. But it really comes from Tom Chi, and he talks about how he was able to take a development cycle of a company that was 3 or 4 years, and he made it into 1 or 2 days. And I really encourage you guys to go read about how he uses this idea of home and away teams to build an entire product in 1 day. But that's where my love of SwiftUI comes in, is the fact that I can go into a coffee shop and walk out with a product that I can put on the App Store. So SwiftUI is Swift, right? It's written only in Swift. It's simple to understand, simple to use. It removes all the legacy next step stuff. It's reactive and declarative. Now we have some new language features that I need to touch on for SwiftUI to work. We're going to get deeper into these in the code labs, but it's going to be, we're going to talk about opaque return types, the fact that we can remove the return keywords. We have function builders and property wrappers, and we're going to talk about all those in a minute. But you can see what a huge difference the new language constructs make. So we can basically say that this struct that normally could not hold a value inside of it can use a property wrapper to do that now. And because we have opaque return types, this view can return a text, an image, a VStack, an HStack, any type that fits into that view. Because we have trailing closures, it's very easy for us to be able to take out all of the complex, all of this. If we didn't have the trailing closure builder, we'd have to have this builder at the beginning of all of our UI framework, which is kind of ridiculous. So one of the nice things is that we have these trailing function builders. So what we see here is the nice clean code we get to write instead of this code, which is very verbose and difficult to get through. One of the really, really nice things about how this system works is you just describe your layout and it builds it for you. So here we can just see, hey, we want an image with some text in the spacer, and then if it's a favorite, then show the image of the star. And this will work on all of our different platforms. So we're just describing our layout and we're being able to build it. And the reason that this is super important is because we're going into an era of foldables, right? And we're going into an era of wearables where we're not going to be able to like think of these things with screens anymore. And we have to really just declare what we want and let the system tell us where we're going to go. And so we're building lots of reusable components. And the way to think about this is you want to start thinking, what is the basic function of this component? And I'm only going to have that in this component, and I'm going to build on components. And Jetpack Compose really builds on this idea of composables. And so when you're teaching Android and you're teaching how Compose works, you're always breaking it down to the smallest component and then composing. Same exact idea for iOS and SwiftUI. You really think about what are my basic components and how can I compose them up? And so that when we move to wearables and all these different screens, we're going to be able to move our code through those things effortlessly. Now, one of the first things that we have to think about when we start an application is, what is our architecture? Because if we don't know our architecture, we don't even know how our file systems is going to be laid out. If we don't know how our file system is going to be laid out, we don't even know where to put our files. If we don't know where to put our files when we start coding, how do we put stuff anywhere? So today, I think we should really work on MVVM, looking toward MVI. So I'm going to do a really quick talk about what is MVVM and MVI. So if we look at our system, we have our iOS device here and some sort of database, and we have our user interactions, right? And so the way MVI works is we have the users, they're making some sort of gestures on the device. And those gestures on the device, it could either be SwiftUI or for Android, it's Jetpack Compose. Those are sending messages to our view, sending messages to our view model. And this concept of a view model is that the view model it keeps track of the state of the application, and it updates the model. So we have the people sending events to the view model. And then the view model, what it does is it talks to the model, and it updates the state of the application, and it re-renders the view. Now, for both Jetpack Compose and for SwiftUI, the view and the view model are reactive. So as soon as the view model changes, you don't have to think about handling any of the ideas behind how do I update my view, or how does my view talk to my view model. They're kind of bound together. So when the view changes, the view model automatically updates, and then the view model talks to the model, gets whatever it needs, and then once it has a new state, that state is bound to the view, and the view changes. So basically what we're seeing is we're seeing a unidirectional cyclic flow between the events of the user and the update from the model. So this is MVVM. Now, a lot of people talk about MVI, which is model view intent. And the way model view intent works is that when the user, it's the same flow, it has a lot of the same features as MVVM, but all we do is we add, when the intents come in, they actually talk on a channel. And that channel, what it does is it has a reducer inside of it. And the reducer takes those intents, and it takes the previous state of the model, and it generates a whole brand new immutable state of the system. And when it produces that to the view model updates the repository. And because the view model and the view are bound, the view automatically updates, right? So MVVM, if you add a channel to it, where you have a reducer and an immutable state, you get MVI. So you have this listening phase that's listening to the user intents. And then you have a business logic phase, which is going to generate a new immutable state that can be used really well in debugging, right? Because anytime you look at your immutable state, you know the exact value for all of the things in your system. And that's why it's really good to have an immutable state. So when the reducer is taking the previous state, which is immutable, and making a new state out of it, which is the new immutable state, that transition from old to new is orchestrated in a way that it's really easy to debug, right? Because you always know the state of your application. And the view model is bound to the view. So as soon as the view model changes, then the view changes. So a lot of people talk about MVI. The first thing I want you to do when people talk about MVI is see if they have some sort of shared channel that the views are talking about, and then look for a reducer and make sure the state is immutable. If they don't have a channel that they're talking about, and you can't find a reducer in an immutable state, they're not really doing MVI, probably doing MVVM, which is also an excellent architecture. So now that we've gone through the first set of slides, we're going to go talk about the language features of Swift. And the way you're going to get to that is you're going to go into Xcode, and under the tutorials, you're going to see tutorials for the Swift language, and you're going to see tutorials for the combined SwiftUI and state management. We're going to go through the language features just really quickly. I had all these open. Okay. And then after this, we're going to take a little quick break, and then we're going to come back and we're going to do SwiftUI. So I just want to talk about the language is a little different. Even when you talk about a function, it has this idea of an external and internal name. So I just want to make sure everyone's on the same page. The first one is the external. The second one is the internal. When you call it, use the external. when you use it, use the internal. Now, this is a little bit cumbersome. So what Apple decided to do is, if you don't have both the external and internal, then both you can just use one. Oh, yeah. I will definitely bump the font up during the break. So basically, this is a little bit cumbersome. So they said if you put a dash in it, then it's a don't care. So then what you see people do is it starts reading like English. You can say, internally I'm using person, externally I'm using on, internally I'm using day. So I have greeting John on Wednesday. This is wonderful, and I try to stick to this. But it gets cumbersome, and I want it to look like all the other languages I'm using. So I can go dash, 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 and then I can call from the call site. It looks like any other language. One of the things we just have to think about when we're doing Swift programming. The other thing is functions. I try to hone this all the time in. People get stuck on it. A function is just a type. It's a string. It's an int. It's just a type, and you can just use it as another type. I understand it's executable code, but by dash I meant underscore. Absolutely right. So sorry. I have to explain. For work, I do all R and Python, and then I teach Android and iOS, and I might actually start typing Kotlin or Python at some point. So just bear with me. Sorry about that. So basically, if we think about functions just as a type, that means that just think of them as an int or a string or some other type, but they're executable. So here we have a function that takes the int and just adds one to it. So its type is it takes the int and returns an int. We can go ahead and just have that as a type, but we can also call that type. And here we're just incrementing. We can call increment, but we can also just pass increment around like a variable. And we can also assign things to that type. And so one of the interesting things is a function is the same exact thing as a closure. It's just that a closure is an unnamed function. So if we were to put a name on this closure, it would just be a function. So people shouldn't get confused about what is a closure and what's a function. They're exactly the same thing, just that the function doesn't have a name on it. So here we know that map takes a function. And here we're basically just multiplying whatever number that is in our map to this multiplier. And what a closure has an ability to do is any variables that are outside the closure, it wraps that variable. So it closes around that variable. And when you start passing that closure around, that variable goes along with that closure. And here we can see that we can just call map with this closure, and it will just multiply 5 by all our numbers. Now, we would never write this closure like this because of inference. We can just actually write this closure by just multiplying it by the number that's being provided to us. I'm going to talk about that for a second. Now, one of the things is if you have a function and you're passing in a closure and that closure is being used again outside of that function, or if you have a function where you are creating a closure inside of it and passing it outside, just remember to put escaping on this. Now, if you forget to put escaping on it, it's fine. The compiler's just going to remind you. Or if you have a function that's mutating something, it's fine. The compiler will remind you just to say, hey, this function is mutating something. So it's kind of nice. The compiler helps us out. And here what happens is I have an array of closures. I'm just appending this closure that's being sent to me. And I'm using it again out here, so I have to mark it with escaping. So we see here that through inference, we can really dramatically limit our typing. And I just wanted to talk about this just really quickly, because sometimes people look at Swift code and they have absolutely no idea what's going on, because it's just so, you know, from trying not to be verbose, it's now pretty obscure. So if we start with a closure where we take two strings and we just want to see which string is larger, so we return a bool. But we know that this sort method can only work with it can only work with strings, right? So we can write this closure in one line, and then we can remove the strings. Now we know it can remove, it's going to return a Boolean, so we can go ahead and remove the Boolean. As I mentioned before, the new language features, we can remove the return keyword. And we don't have to use S1, S2, we can actually use $signs. And because we know that this argument takes two values, we can remove that, right? So instead of writing this verbosity, we can just say sort and give me back whichever is larger. This completely makes sense to me, but as someone new to Swift, they'll look at this and they'll be like, yeah, that makes absolutely no sense. And, you know, because if we have trailing closures, code can start looking really weird. Like we have this takes some sort of a closure. Great, I understand you're passing in a closure, the argument for this guy. But because we can move trailing closures outside of the parentheses, what happens is we wind up with something that looks like this. And here you look at it and you go, what is that? Is that a method call? It looks like a function. That's, if I put function here and close it, then what's going on here, right? And it's like, no. This is the argument to this function. And as we get deeper into SwiftUI, you're actually going to be seeing a lot of this stuff in its full force as you know, we cut all the verbosity out of the code. So all of this CodeLab runs. Oh wait, sorry, a little bit more. Okay, so now we're just going to talk about the difference between classes and structs real quick. So a class is a reference type, which means that every single time you pass it, you're gonna get the same value. A struct is a value type, so a reference type and a value type. That means that every time you pass a struct, you're making a copy of it. Now, this is really wonderful for protocol-oriented programming, because with protocol-oriented programming, as you're passing around all these structs, you don't have to worry about who owns the memory. Do I have some sort of crazy cycle that I'm building? Did I clean up? Am I going to be talking to another object that another system has a hold of, and we're going to be talking all over each other, and we're going to get into a nightmare. So the beautiful thing about protocol-oriented programming is, one, most things that you're working with are value types, so you don't have to get into any of that. And because you're working with protocols, you're not working with inheritance. And so classes have inheritance, and usually with structs, what we do is we build protocols on them. And what we really want is the interface, right? So we want to do, the interface is the beautiful thing about inheritance. So actually inheritance sucks, but interfaces are wonderful. So if we can just keep using protocols with structs, we get the benefits of interfaces without having to worry about inheritance. Because inheritance, when you have an object, you inherit everything that object inherits from. And a lot of times you don't want that baggage. And so what you normally do is you want, in Java programming or Kotlin programming, what you say, because you don't have protocol-oriented programming, is you want to have always to limit your inheritance, and you want to use composition over inheritance, right? So whenever you're doing Java or Kotlin, you always think to yourself, composition over inheritance. Why? Because inheritance a lot of times brings over a lot of baggage. With Swift, we don't have that, because we can do protocol-oriented programming. Now, one of the things is that people like to put extension functions on the structs so that they're a lot easier to work with. So here, like what we see is we have a person, and we can put an extension function on that initializer so that when someone gives us a name, right, we can split it, and it just makes it easier to work with. So a lot of times, extension functions are used to make our structs a lot easier to work with, and also our classes. So when you're working, I always want you to reach for a struct, and I always want you to put a protocol on that struct. Now, there are some times when you just have to use classes. When we talk about later in the day, we're going to talk about our model view model. Our model is going to be a class because we only want to have one state in our class represented for all of our views. So that is going to definitely be a class. Now, some of the nice things about a class is they have built-in deinitializers, and they come with a built-in identity. For a struct, we actually have to have a function that has identity where classes have it built into it. So that's really when you should be using classes and structs. Let's see here. I just want to talk about property wrappers really quickly. So what a property wrapper allows us to do, a new feature in Swift 5.2, is it gives us an ability to play with our properties as they're getting initialized or when people are trying to use them. So here I have this property wrapper that's called capitalize. And any string you send to me, right, either through initialization or when you try to set it, I'm going to capitalize it. So with this very clean code right here, just capitalize on the first name and the last name. When you send me, when you try to initialize me, what you'll see is I'm going to capitalize them. Really clean. And I just want to point out something a little odd so no one gets caught by it. But you could actually have a property wrapper that does something different when you try to set it as to when you initialize it. So this is a bug, right? When I call add one here, when I'm initializing it, I'm adding 2. And when I'm setting it, I'm adding 1. So if you go through this, what you'll notice is when I initialize it, it adds 1. Okay, I will fix this error in the break. But when you run this, what you will notice is when I initialize it, it adds 1. But when I initialize it, it adds 2. But when I use it, it actually adds 1. So that's just something that we can actually do with property wrappers. And then the last thing I want to talk on is a couple Swift 5.2 features. And the first is that you can use a key path as a closure, which is really nice because if we have this struct, which is a user, right, and then we're going to go ahead and instantiate an array of those guys. What I can do is this would normally take a closure. It looks like this, but with this new Swift 5.2 feature, what I can do is I can just pass in this key path instead of the closure. And it just makes life a lot easier to work with. And also, we have now a way to make our structs callable. And what I mean by that is we just have this call as a function. And then when we build it, we can just go ahead and call it as a function. And it will actually call this function for us. Now, we could do this ourselves by having a function that is like call this function, but you can see it looks completely odd, right? So here, I'm just calling my struct without having to put this crazy stuff on the end of it. So let's see. Yeah. So if you play with this Colab during the break or a little bit later, what you'll notice is you can even do it on a mutating function. So I'm going to go ahead and I take a break here real quick. I'm going to look at Slack. I'm going to fix that last code lab that didn't run. I'm going to give you guys a chance to play with these code labs for a second. And then we're going to come back and we're going to talk about SwiftUI. So if we look at our schedule, I wanted to get into the SwiftUI portion of it around 10. So we're doing great on time. I think let's start at, let me see how people feel. I think I'm going to say 8:50. How do you guys think? If we come back at 8:50 and start with the SwiftUI slides and tutorial. Okay. Okay. So yeah, we will be back in 15 minutes. I'm going to fix the collab. Oh, sorry. Oh my gosh. Yes, my bad. 9:50. Sorry, I'm an hour early. Let me get it all right again. Sorry. So let's come back at 9:50. That will give us. Am I saying that right? Yeah, 9:50. And that will give me time to fix the collab for you guys to look at the collab and bring up any questions. And then we're going to come back and we're going to dive straight into SwiftUI. And I'm going to explain how the layout system works. So the next time you guys put a whole bunch of SwiftUI stuff in the UI and it goes to the wrong place, you'll know exactly it didn't go in the wrong place. It's how the layout system works. Yeah, 15 minutes from now. All right, so let me fix the collab and then we'll be back in 15 minutes. All right, thanks you guys. All right, I'm glad everyone's helping each other on the Slack channel. What I'm gonna do now is, can everyone hear me okay? Like, are we, make sure. Okay. Let's see. Okay, excellent. Excellent. All right. So we're gonna, I kind of went really quickly through the Swift stuff because I figured we're pretty much comfortable with Swift. We're going to go a little deeper with the SwiftUI stuff, and then a little bit more deeper with the state management, and then a little deeper with the combined stuff. All right. So let's look at our schedule real quick. We're going to do slides 23 to 51, and then we're going to do playgrounds explaining how all this stuff works. So, excellent slides. All right. So in the beginning of all this, I flew around the country and I talked to a lot of people about moving to Swift. At that time, I think it was Swift 1.5, and everyone was like, you know, you're an idiot. Swift is a flash in the pants. There were even engineers at Apple saying that there's no way that Swift was going to survive. It was not going to, it's just an incubated idea inside Apple, and it's not going to go anywhere. But there was just too much beauty in the language. You know, there was just, it was just it just looked right. So I was flying around, I was telling everyone, you really need to move to Swift. It's going to be the future. And everyone said, you're absolutely nuts. It's not going to go anywhere. And now I fly around the country, I tell people, you really need to move to Swift. And they're like, you're an idiot. Why would we not even be on Swift? So I went from being an idiot to being an idiot. And I kind of like fly around and tell people, you know, skate to where the puck is going to be, right? So work on SwiftUI. I understand it's only on iOS 13 and above, but Apple moves really fast with their operating system updates. On the Android side, it's true, there's so much fragmentation, you can't be on the latest. In fact, I think the latest numbers for Android were 0.021% were on the latest release of Android. It was just ridiculously small. But on the iOS side, today, I just checked, 92% of the machines are running iOS 13. That means that 92% of the machines out there can use SwiftUI. So the people who started using SwiftUI a year ago, 92% of their customers can use it. And what's interesting is, sorry, could you guys not see my screen? Hopefully you can see my screen. Okay, cool. So, yeah. Okay, great. Sorry about that. Yeah, I didn't have sharing on. Okay, so as you can see, I just pulled this down. 92% said that are now on iOS 13. Now, from my point of view, I don't want this to sound harsh, but the reality is that 92% are probably the people who are going to spend money on my app. The people who are on the 2% who are earlier than iOS 12, nothing against them, and I will definitely try to support them as much as I can. And I don't mean this to sound odd. It's kind of I don't like saying this statement, but in the back of my mind, I do think to myself, the 92% who are on iOS 13 are probably where my money is going to come from. It's not a good thought, but anyway, moving on from that. Yeah, so today I only in iOS 14 can you use a SwiftUI map, and I'm totally okay with that. I'm building a shared bike app. By the time I'm done, iOS 14 will be there for me. So one of the things I really love about SwiftUI is trying to put storyboards in source control was an absolute nightmare. And trying to understand when you looked at the source code for all the nibs and all the other stuff, I just could not figure out what was going on. And now, when I show you how navigation works in SwiftUI, you can just immediately look at the source code and know exactly what all the code's doing. Because the source code is so simple, you can make really great tools on top of it. And we don't have something like Storyboard coming yet, but third-party people have already started building on it because it's so easy to manipulate the source code and know exactly what the code is doing, that the user graphic interface on top of something like that is going to be really easy to build. And the Swift compiler is now checking our UI for us, which is just wonderful. And the way that you go from the UIKit to the SwiftUI naming convention is basically you take the name that you were working with in UIKit and drop the UI part of it. So if you were working with a UI slider, you're just working with a slider. If you were working with a UI button, now you're just looking for a button. So the name convention should transfer over. Before WWDC, I would go through this list because we still needed UIKit to be a part of our system when we built SwiftUI. But now, when we build, we don't have to worry about any of this legacy UIKit. Now, don't get me wrong, I love UIKit. I've worked a lot in UIKit, but I think it's time for us to move to a declarative way of building. The Canvas tools are really amazing to work with, and they give us a really fast iterative cycle so we can build our UIs quickly. Here, you can see I have a vertical stack, and it has two texts, and I'm just changing the text, and in real time, I can see my changes. I will explain how layout system works in a second in the code lab, so you can, code labs, it's Android, in the playgrounds, and you'll understand how the layout system works. And the beautiful thing is, right inside the tool, we get this beautiful way of looking at all the different ways that we preview. So here we can put our wearables and we can put our foldables. and know that we're getting the right UI for all of our systems. We just declare it here and it magically works. One really nice thing that they have right now is we have some discoverability built into Xcode. So if you control click on any type of UI component, you can get all of its modifiers. And so you can kind of play around with it. That's that. Also, if you hit the little plus button, and I'll demonstrate this, you can see all the different views you can put in your palette. So there is a little bit of discoverability built into it, but I truly believe storyboards will come back, and drag and drop and control drag and drop, all that stuff's gonna come back. They just haven't built it yet. But when it does come back, you can change the source code, or you can change it in the UI, and it'll be really easy to determine what's happening, because SwiftUI is so easy to work with. And one of the things is, like, we should always think about components. So whenever you're building, think about how you want to build out your components. Here you can see we can inspect our components and change the modifiers, and then think about how to put them into stacks. And we've been doing this for a long time. So in UIKit, when we build, we have that like click enable button to look at your different stacks, right? So we were always constantly taking in UIKit our components and putting them into stacks. Nothing's changed, right? We're still going to be taking our components and figuring out what we want and putting them into vertical and horizontal stacks. Same things that we were doing in UIKit. One of the nice things is that Apple is building forms of UIs that we always use, right? So there's going to be more of these coming. But if you needed a form, now you can just say, hey, I need a form with these sections, and this is what I need it to look like. And it brings up what iOS HIG would say, this is what a form looks like. And if you go on GitHub, people have lots of really nice SwiftUI components that look like the UIKit representations. And so we can just start using these things without having to build them. We can just say, I want a form, I want a login, I want a registration page, I want a whatever, and we just get what we need. Another good thing is we can group, and we can put modifiers on an entire group of components. And if you, I believe the limit is 10. If you try to put 10 views together, it doesn't show up. And what you have to do is you basically have to break them up into groups, and then the system will show it. And it's really, really easy to build custom views. And this is the most beautiful part of the whole thing. So we have this really beautiful UI here, and it took just a little bit of taking our image. And the way that images work is you just put them in your asset catalog right here. Just put the image in there, and then you just say image with the name, and the image will show up. And then we can just clip it, put a little overlay on it, and shadow it. And so really, if you can't find what you're looking for, it's very easy to make custom views. And then what you do is you take that custom view, you package it, you give it a name, and you put it on GitHub, and then everyone gets to use it. Now, I have built entire applications without any images in it, because I was just using the system fonts. And now I think after WWDC 2020, there's a system font 2, SF symbols 2. So we have all these wonderful symbols and emojis. So I was able actually to build an entire application between emojis and SF symbols. And my download was really small, and I had all the assets I needed. So it's really wonderful. And again, one last time, I just want to really talk about that in the tooling itself are ways for you to take your different views and extract them. So always think about making components, and the tooling will help you do that. And this is probably one of my favorite parts of SwiftUI. control dragging and working with storyboards and all that, it was great, and prepare for segue and all that. But once I put into source control, it became really hard to figure out what was going on. Navigation under SwiftUI is so intuitive, it's crazy. And it works on iOS, wearables, foldables, it's all coming out. Basically, you have your view and you say, you know what, I want to set up some navigation. It goes, okay, what do you want to do? Well, I want a navigation link with this text in it. And this view, this is where I want it to go when you click on it. That's it. So this view could just be a text. You could just have like text and some text in here. Well, that's a view, right? And when you click on the link, it takes you to that piece of text. And when I look at source control, right, I can tell exactly what my navigation is doing. Now, when storyboards comes back and I get a graphical image of this, I can easily go between the two, looking at the source code or looking at the images. And passing data from one view to another is just calling that function and passing arguments. Hooray, hooray, right? So basically I have my view here. I'm passing it two pieces of text. This is my view. It's got a V stack. It's just gonna show those messages. And I just call it and it just goes from this view to the next view. And we'll have some examples of this. Man, building a UI table controller, it's just a list, right? Most people probably already know this, but I'm just so enthralled by this, I just have to say. So this is just an array, and basically I'm just passing that array to this list, and all I have to do is, when I pass it in, I get my UI table view, which is really wonderful. And I have to say, Jetpack Compose on Android does exactly the same thing, right? Instead of having to make a recycler view and then make a template for that, and you know, generating all this stuff on Android, which is just a lot of work to get this list to show up. All you do is you just pass into the list component an array and it builds it. And here, if we want to make a detailed view, it's really easy. We just make this navigation link and we send in the detailed view, and it builds that, this arrow for us automatically, right? So I have an array, and that array has some detailed information on it. And I'm going to show this when we get into our project. But basically, we're going to have a detailed page. Have an array. This data has some more data in it, and you just pass that data into this detailed view. And the way you get there is you put this navigation link around this detailed view. Sorry, you send in the detailed view, you put the navigation link around the row, like that. So you have the row that you're displaying, and you just put the navigation link around the row, and it sends it to the detailed view, and the system will build this for you. Now, as you run on different systems, because you're declaring what you want, if you're on a phone or if you're on a tablet or if you're on a watch or on a wearable or on a foldable, it'll figure out what the right markings for the UI should be so that it goes from the row view to the detailed view. For a phone, it's going to put this little marker here. And if you want it to be able to delete this, I believe all you do is you put like editable here. So it makes it really easy to work with lists. And it's really simple to build UI logic, right? Look at this one piece of code. This one piece of code makes all of this interaction possible. Now, when you're in XCode, when you're doing a preview, if you want to see what it looks like live, there's a little button here. Well, now I think they changed it. It's now up here. But you can get live previews right inside of XCode. And so here I was taping my live preview for this little bit of code that I got from the Apple site. But basically what it does is it just looks at this, in here, this little bit of data structure has if it's a favorite or not, right? And all we do is we look at this and we say, okay, if it's a favorite, then go ahead and add it in our navigation link. If it's not, then don't show it. And so basically what happens is by just flicking this one UI control, it's going between our favorites and our not our favorites. And I just think this is absolutely a wonderful way of doing it. And it's funny because Jetpack Compose on the Android side does exactly the same thing. So I think as we get deeper into the morning, you're going to see how beautiful it is that we can just put in logic into our UI and we get these really nice graphical changes. The interesting thing here is things are moving really fast and I'm okay with that. I'm much happier when I get a new version of Swift and they've broken all my code, knowing that in 10 years down the road, everything's going to be better for people coming. So it's true that the navigation button has been deprecated several times over while they're trying to figure out how the system should work. But every time they've changed it, it's gotten better. So I hope you guys agree. I hope you're okay that when Swift 5.5 comes out and it completely destroys all our code, we understand it's going to be painful, but we're thinking about future generations. Animation was built absolutely into every thought about SwiftUI. So if you want to animate something, you can just put .animate at the end of it or with animate on a toggle, and it will animate beautifully. And I have a code lab for that. So I used to talk a lot about framework integration, and it's really simple to do. But I think just for this session, we're just going to stick with SwiftUI. So now what we're going to do is we're going to jump over to the keep wanting to say code labs, the playgrounds, and I'm going to go through some nice features of SwiftUI and explain how the layout system works. All right. Okay. So we're going to go back to XCode, and what we're going to do is we're going to go to the SwiftUI playground. And here we have a whole bunch of playgrounds that we're going to play with. Let me check something really quickly. Okay. Oh, I want to preview XCode real quick. So when we're in XCode and we're looking at something that has a view in it, okay, let's go ahead and resume this real quick. We're going to be able to get a live representation of what this UI looks like, right? And we can actually come over here and make it live. So if you notice right now, I can't get to what this thing looks like, but if I push this live preview button here, right inside XCode, I can test my UI, and I can actually see, why isn't this working? Okay, hold on. Oh, okay. Maybe navigation in XCode doesn't. I thought I tested this. Okay. Anyway, maybe navigation not, but all the other features do work properly, and you can actually test it. And the other thing I wanted to point out real quick is if you push this plus button, you can actually see all of the views. So this really helps with discoverability that you can go ahead and put into your palette. And it gives you really nice detailed explanation of how it all works, and code you can just cut and paste real quickly and drop it into your Xcode and try it out. Also, the last thing I want to show here real quick, if you come to this guy and you click command click, you can get the attributes of this guy. But you can also come over to your panel, and when you click on something, click on this, and it will bring up the attributes of that UI piece that you're looking at, and that also helps with the discoverability. All right, so let's now, man, my machine's dying. Let me see. We're gonna go back to the code lab. So let me go ahead, pull that out. Okay, so we're gonna talk about layouts really quick and how they work. This is probably a really large part of frustration of people, but once you understand how the layout system works, you're not gonna fight it anymore, and you're gonna understand it doing exactly what you're asking it to do. So we have a little bit of content here. It's just gonna put hello world on the screen, right? So let's go ahead and look at what that looks like. The way this works in the playground is you have a playground, and you're gonna show the current, and then you just set that to the content view. So here we have a whole bunch of content views, and I'm gonna cycle through it. So first one we're gonna look at is this guy. So we come over here, and we run this. Okay, so I have a little hello world. We're all really happy with that little guy. How did that happen? So what happens is, this is a little, okay, it's gonna be a little bit, okay. So this content view, he is layout agnostic. He doesn't care about his size at all. So when SwiftUI talks to him and says, what is your size? He goes, I am layout neutral. I'm agnostic, I don't care. Then what happens, SwiftUI talks to the background color. Background color says, okay, how much room do you need? Background color says, I don't care. I'm agnostic. I'm neutral, layout neutral. So then he talks to his child and he goes, how much room do you need? Well, I need exactly enough to hold hello world here, this many pixels by this many pixels. So that's passed up to background color, and background color, okay, I know exactly how much I need, which is then sent to content view, and content view says, okay, I know exactly how much I need, and then he displays it. Now, if we look at this guy, that conversation looks the same. He goes, hey, content view, SwiftUI says, how much do you need? He goes, I'm agnostic, I don't care. The background color says, how much do you need? Nah, I don't care. Then he asks padding. Padding, how much do you need? He goes, I need 20 more than whatever my child is. Then we get to this hello world. The hello world needs, I need exactly this much. Padding goes, okay, I need 20 around that, all the way around him, plus 20. Background color says, I need this guy, plus 20 all the way around. Content view knows how much he needs. He tells SwiftUI built it. So what does that look like? So if we put one here, save it, move, run it. Okay, so we have a little bit more red. So what happens to the next guy? Yeah, hopefully you guys are getting a pattern here. What this guy is saying is, hey, Mr. SwiftUI goes, hey, Mr. Content View, how much do you need? Then Mrs. Content View goes, I'm agnostic. I don't care. And then they talk to position, and position says, well, how much do you need? And position says, I'm going to be positioned at 100, but I'm agnostic. So then the background color, I agnostic. So finally we get to hello world, and hello world knows his size, and it comes back up. Now we notice that position is wrapping the background color and the hello world. So the positioning is going to be applied to both these guys, right? So we read from the bottom up to see who's wrapping who. Now, if we run content view number 2, what we're going to see, and content number 3 is going to blow our mind, but content number 2 should be reasonable. So he's reasonable. We got our position, right? And we got our word and everything. But if we go to content view 3, it gets a little crazy, because if we read 3, what happens is SwiftUI talks to content view, I'm agnostic. The color red says I'm agnostic, and then position says I'm at this position, but I'm only wrapping the hello world, right? So when we come back up through this, we see position is only positioning hello world, and the background color is only getting the size of hello world. So if we were to run this, we get this, right? So the color does not know exactly, sorry, the position does not know exactly where in the field he needs to be. So when he reported back up to the color, he didn't know where he needed to be. So color was kind of confused about how big his space was. So he went ahead and he took the entire background area, right? Because at this point, position could be off the screen, and the color red has to cover wherever the position is. So because the position didn't know quite what his child was and where he was going to be positioned, he couldn't really report to background color the right area. So background color actually just had to take the whole thing. So, you know, that could be quite confusing if you build it this way. Now, if we were to simply flip them back, then we would get exactly what we expected, because position is wrapping the background color, and the position and the background, then the background color knows exactly how big he is, and the position knows that he's wrapping only these two, so the background color is being bound by the position. Here, because the background color is not being wrapped by position, he's taking the whole screen. Now, to get a little deeper into how this whole system works, to make it even more clear, we have content view 4. This is an agnostic. So he's going to talk to background color. So, okay, so this is the, sorry, this is what I meant to say before. Even for me, this is like a little bit much. But for the content view 4, what we're seeing here is background color is wrapping both the offset and the text. So background color knows exactly, let me think about this for a second. Sorry. So background color here is going to get the size from the text field, but it's not going to get the offset. So look at what this looks like. This is the example I was thinking of before I confused myself. Just jumping ahead. Let me show you this. Okay. So this is the example I was talking about before. Okay. So what's happening here is what we're saying is the size of the background color is coming from the text. But since the offset is not wrapping the background color, it's not getting the offset, right? The background color is wrapping the position and the width of the text. So when the SwiftUI system asks the content view, how much size do you need? He goes, I'm agnostic. He talks to background color, how much size do you need? He goes, I'm agnostic. He talks to offset, and offset says, I have no idea, let me talk to my child. The child comes back and says, I'm this width, this height at this position, this width, this height. He gives that back to the background color, but he doesn't give him the offset because the offset is only wrapping the text. It's not wrapping the background color. So he now knows his size, but he's not picking up the offset. And so to fix it, like I said, you always read, you always use your modifiers always go from the bottom to the top. Here we see that the offset is wrapping the background color. So if we go to that, run content view 5, what we will notice is now that the color is being wrapped by the offset, it's being moved. And that's why order really, really matters when we're working with SwiftUI. All right, that's layouts. So next, we're going to talk about, I hope that made sense. I was like, I got a little confused myself on some of those points. Okay, so now we're just going to talk about, we talked about modifiers and how they wrap up. We're going to talk about ZStack, HStacks, and ZStacks super quick because I just want to make sure we're all on the same page. This, we want this to go live, preview, excellent, run. 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 Start. Okay. Excellent. Close this. All right. Try to get this to 1. Run. No. Run. Try preview. Wow. Yes, excellent. Okay. Now, we might have to take a break just so my machine doesn't catch on fire. Okay, so super quick. Now, when we're building, we always want to build in components. And the way that this really helps, the way that SwiftUI helps us do this is with HStacks, VStacks, and ZStacks. So here I have an image, and I have put that into a horizontal stack. That horizontal stack is, there's 2 components in that horizontal stack, which is the image and a ZStack. The ZStack has 2 rectangles in it, 1 green, 1 red. And that's all wrapped in a VStack. A VStack goes vertically, a horizontal stack goes horizontally, and a ZStack is in and out of the plane. Now, the way I remember horizontal is you think about the horizon, and the horizon is flat. It goes across a plane, right? So it's a row from right to left. Vertical goes up and down. So whenever I think of H, I think horizontal, horizon, left to right, VStack, up and down, vertical, ZStack, in and out of the plane. Default for in the plane is 0. So if you don't give the ZStack anything, it's going to be in the plane. If you want things in front, right, you add numbers to them. If you want things behind, you subtract numbers from them. So the plane is 0, behind it is negative, in front of it is positive. And if we want to look at what that looks like is, see the red here is neutral and the green is up 1. So we have this ZStack with the red in the back and the green in the front, because I'm just making 2 rectangles. and I'm putting the red rectangle at 0. And you can play with this. Like the purpose of all these, keep saying I code that. All these playgrounds is so that during our breaks and afterwards, you guys can go play with this. So what I would say is make this 0 and make this negative, or make this, make this, make this negative and make this 0. You'll get the same thing. So play around with this a little bit. But the most complex thing here is just the Z stack. The rest of it is, it's just going to stack it vertically or horizontally. Now, the best thing you can always do is put colors on these things. So whenever you have a stack and you're trying to figure out what it's doing, just go ahead and put a border color around it, right? So we have a border color around all these different H stacks and V stacks. So I can actually see, what my different, where my different stacks are. And I kind of left this in the code lab so you guys can bounce these borders around and figure out how these stacks are being laid out. So hopefully that explains that. Sure. Okay. The next thing we're going to look at real quick are lists, forms, containers. Okay. So unfortunately, playgrounds can not do the kind of, it can't do navigation. So unfortunately, it's not the best place to work on this stuff. But we have examples. We have other examples that we're going to be playing with. So now, let's see here. I want to get rid of this guy. And then forms. And this one's on forms. Oh, okay. So this is XCode Beta 4. I thought it'd be more stable. It's not. Sorry. But I had to use XCode Beta 4 because we are using SwiftUI Maps, and SwiftUI Maps only runs on iOS 14. And the reason we're using iOS 14 is because by the time you guys, or us, me, everyone, are up to speed on the, building our apps, our users will be on there, right? So we're learning and building on iOS 14 because by the time our apps are done next year, they're going to be on the platform. So unfortunately, we're always going to be having to work on the beta stuff. Okay, let me do a new. Okay, a new window. Okay. Oh, we already have one. Sorry. So with one window, I'm editing. With the other window, we can see what's happening. So I'm going to close this. Some forms here. I'm going to run this. Please show up. Excellent. All right, now we can get rid of this. Okay. All right, so for the list, we will definitely look at it when we do the project. But for the form, I just want to point out that it's very easy to build a form. It's basically built right into SwiftUI for us. We build these sections, which give us the various sections that we see in the form. And then inside the form, we can just go ahead and put our various UI components. And here we can see it's so easy to build with a picker, right? Because all we do is we give it our options in a loop, and the picker will generate this really nice UI for us. And so building forms is basically built into the system. Okay. Animation. So let me do animation real quick. All right, let's run this. Right. I want to take a second here and just show you how amazingly easy it is to use the Swift Package Manager, built right into Xcode. So we're going to go and we're going to grab this tool, which allows us to bring images from the web. Really popular tool. So we just go to GitHub and we just get the GitHub link. And come over here to Xcode. And we go to, okay. It's, wow, there's too many things going through my brain. It is, okay. Okay, I'll come back to this. Right. But it's basically, you just take the GitHub repository and you put it into your, let's see. Libraries. Gosh, I don't remember where libraries are. You guys remember where libraries are? Where are they? I have too many things going through my mind. Where's the Swift Package Manager? Swift Package Manager. Oh, thank you. Okay, thank you. Okay, put this in here. Super easy. Put this in. All right, I just want the latest version. Too many things going through my head. But I was like, where did I put that? But now, boom, right? So simple, right? And you always want to take the dynamic library. The problem with the static library is that it tries to put every single copy of the software will have its own version and its own copy of the library, which is just not what we really want. We just want to have it dynamic, so every single piece of our software can use this. So now, if we look at our package dependencies, we have our necessary, and then all we have to do is we just import it. So super easy to use the Swift Package Manager. It's just right under File, Swift Package Manager, add the dependency, go to GitHub, get the link, put it in, you're done. It works. I highly, highly, highly encourage people to not write software. Don't write code, whatever you do. And if you wrote some code, put it on GitHub so we can all share it and use it. Okay, so animation is actually built right into the system. All right. Sorry about that. Man, there's just too many thoughts going through my mind. Now, if you notice, when I press me, we get this really smooth, beautiful animation. And I get that all from one line of code, right? So basically, I have this bit of code. It has a button on it. And that button, when it has press me on it, and an image, right? And low divider, I have this bit of code here. And if this bit of state is visible, then I'm going to be at one position in my Y offset. And if it's not visible, I'm going to be another one. And with my animation, I'm saying ease in and ease out. Now look how ugly this is if I don't put my animation in here. Okay. Right? It's just crazy, right? I mean, it just jumps. And then with one line of code, because animation is built into the system, right? When you run it, it works beautifully. And every piece of UI you have has an ability to be animated built into the platform. So I highly encourage you when you're working with like buttons to stop and start stuff. Anytime you're clicking on something that is transitioning state, put animation on it, right? Because then you get this beautiful animation. Also, if you notice here, we have a nice smooth transition between this and lots of different types of animation. You can ease in, ease out. You can have a spring animation. And again, the animation just, it doesn't go on the button. So that when you have like this button, the action of this button is it changes the state of the toggle. And because the state of the toggle is being observed by the view, when it changes, it re-renders the entire view, right? We don't put the animation on the button. We put it on what we want animated. So if this button is animating 15 different things, we don't animate it. That button, the 15 things that button animates, doesn't animate the same thing. It goes on the UI component that you want animated, so that each UI component can have their own animation. Now, if I take that out, look how disgusting this thing gets. So before it would turn really, really nicely. But now it just jumps. Like you can't even tell what's going on, right? But because SwiftUI has animation built right into it, highly, like, think about this stuff all the time. What can I animate? Because animation really helps the user know what's going on. Now, of course, I made it gross by changing my rotation effect from 10.5 to, but you probably just want this to be like 10.5, something reasonable. Now, the other thing is you can control the speed of your animation. And so it's really good by changing the duration of your animation to actually see what is happening inside your animation. So I highly encourage people to change your duration. Okay, so that's animation. Always think about what you can animate. And the other way you could do it is you could wrap the animation with animate. So I should put that in that code lab too. I will work on these code labs, I think, over time, and I'll add more to them. I should have added the wrapping of the animation. Okay, and the next thing we're gonna talk about real quick, trying to fly through all this stuff as fast as I can. Okay, we're gonna talk about user input real quick with gestures. Gestures are really easy to work with. So I really want to get to the state. Okay, gestures. Okay. Okay. Input. Take this thing running. So we can close it. Okay, excellent. Now, for user input, I just wanted to point out some simple things. We are going to talk about state in the next section very quickly, but this is reactive programming. So as this state changes, it tells the view it needs to re-render itself. So all these states that we're setting up help us keep our UI and our data in sync. And here we have a slider. So this is how you would build a slider. We have a toggle, and you can play with all this during the break. We have a picker and a stepper, right? And so basically, the fact that I can move this and it dynamically is updating my UI because of the way that reactive programming works makes it a lot easier for me to work with my UI. And here we can see a simple if statement. The logic of a simple if statement is changing my view. So what is that? That's the toggle, right? So if I just look at the toggle, this simple if statement, right, is making this entire toggle work properly. Man, I just love that. And once you are enjoying working with this, when you go over to Android, it's exactly the same thing. They're just using the Kotlin compiler and Kotlin logic to generate a declarative way of how the UI should work. So I'm just declaring, hey, with this if statement, okay. So because we get to just declare using logic what we want our UI to do, it's going to work across all our different devices, our phone, our wearables, our clothing, whatever. And it makes us reasoning about the UI much easier. So okay, that's kind of what I want to point out on that. And then we're going to do alerts and action sheets. Okay. So trying to keep on schedule. Alerts here, alerts here. Okay. Let's run this. And during the break, I hope you guys get a chance to play with all this stuff. I meant this to be more of you guys playing with the code labs, but I just want to give you an idea of what, hopefully afterwards you guys will go play with these guys, go play with these code labs. Okay, now, really quickly, it's very easy. Again, we have some state. I'm going to explain how state works in the next section. But basically, if the alert is true, then we're going to show the alert. And then once the alert is pressed, we're going to go ahead and dismiss it. And then we also have an action sheet. When we push the button, it will be true, and the action sheet will pop up. And then these buttons will show how the default works. And so we have our little action sheet, press it, our alert comes up, click it, it goes away, and then we can bring up an action sheet. Again, I'm just showing this to you so that at a later point, you can go play with this playground and get deeper into how alerts and action sheets work. But they're absolutely gorgeous. Like, man, for one line of code, this is beautiful. And you can put you can put an entire form in here so you can get people's input and then read that input and then send it to your server. And the Apple HIG talks a lot about when you should use alerts and action sheets. And SwiftUI bakes in the Apple HIG, the Apple Human Interface Guidelines, right into the code. So when we're doing Swift, we're following the HIG, which is really nice. And I think we might be close to finishing this section. So for navigation, I'm just going to say that we are going to talk about navigation, and it's super simple. It's kind of what I showed before about you just have a link that goes to another view, and I will demo that when we get to our final, when I go over the project. But it's really simple to do. You can't do navigation in playgrounds, so I couldn't show that. And I think I'll be good. And then data flow, I will definitely get into data flow and combine in the next section. So right now it's 8:45. I was wondering another 15-minute break so people can play with these set of Okay, is it right now 8:45 in Mountain Time? Oh, sorry. I'm going backwards. I subtracted an hour. I need to add an hour. Got it. Okay, sorry about that. Okay, it's 10:45 right now. If we could come back in 15, that'll give people a chance to play with both playgrounds. And then we'll come back at 11, and that will put us on track to do all the state management. Right, so that's 15 that's 15 minutes Mountain Time, not 15 minutes Pacific Standard Time. Good point. You guys are too smart for me. That's hilarious. Okay, so yeah, if we come back in 15 minutes, and I will go through @state, @binding, @state object, which was just added recently to 5.2 because of a bug with @observable object, which is really important. And then we're going to talk about app storage, app seed storage, environment object. So 15 minutes Mountain Time, we'll be back and we'll get into state management. Oh, and one last thing. I know that the QuickBird Labs is having a session at 1:30. I think that after we get through our next section, that will meet all the prerequisites that they needed for their lab. So hopefully they're recording their lab, and people who are not up to speed to follow their architectures will be up to speed after the next section. I'm trying to, that was my hope. So we're gonna do slides 51 through 61 and then go through UI state management, and then we'll follow that with combine. Okay, so see you guys on the start of the next hour. Okay, thanks. Okay, I think we're back. All right. Let's see, we have the screen sharing. Okay, cool. So we're going to talk about state management real quick. It's probably a lot simpler than people make it out to be, but I'll let you be the judge of that. So start with the slides real quick. So one of the main problems we're having with working with UIKit in the old system was that we had a controller, and this is not unique to iOS development in any way. MVC always had an issue that it was very, very hard to test. So people moved to MVP, but MVP wasn't reactive. So it was also difficult to work with. So then people moved to MVVM. And because now with MVVM, all you do is you change the state of your application and your UI automatically reacts to that. We don't need the controller. And so it makes it much easier to reason about what our program is doing. And it really allows us to handle much more complex UIs in a much simpler way. But now we need to manage our state. And we have a couple tools to do that. Add environment, @binding, @state, a normal property, or a bindable object. At the end of this, I'm going to give you a flow chart to figure out which one to use when. It's very simple to follow. So if I make this sound complex, it's not. With that final chart, I think you're going to be like, oh, okay, I get this. So state and variable management, it requires only 2 steps, right? Basically, you define your data, your single source of truth. It could be CoreData, it could be whatever you're talking about. And then once you bind to that, you've basically made a dependency. And now SwiftUI can work with that data and it will react to that data. So all we do is we define our single source of truth and then we bind to it. Now, sometimes if you have multiple views using one bit of data, definitely don't want to replicate it through all the views, right? We want to move that to the highest common view that uses it, and then use it at state, and then pass that bit of management down. And I can show you how to do that in a second. So basically, the at state property wrapper, it is when a view itself wants to generate some piece of data that is mutable, and it needs to be able to use that mutable data. So this a good place for this is like the state of a button, right? Or if something should be toggled. Basically, only a view or a child view needs to know about that piece of data. And that's where we use at state. So normally when you're reaching for at state, just think to yourself, do I really need to use a state in this view? And is this the only place that this data is necessary? And if it is, then use at state. Otherwise, you're probably going to want to use at bindable object. So now, if we have a view that has a state in it, and we want to give that to our children, how do we do that? And basically, we use at binding. And what happens is here, this string, pass-in data string, is not, the memory for this is not being instantiated inside of this view. It's being passed in. And from the call site, it looks like this. In the state that in the view that I want this bit of data to live in, I say at state, and I always mark it private because this should only be used inside the state where it was created. So it's really, really a good idea to mark anytime you use at state to make a new bit of data that your view is going to use. You definitely want to mark it private, right? So we have this var here, and this is going to get a lot, it's going to make a lot more sense when we get into the playgrounds, because I'm going to actually go through this again, and I'm going to explain like why we have to use this, and you know, a struct cannot generate memory on its own. So we're going to get into this, but right now I just wanted to introduce the terms. So just bear with me. This is going to make more sense when we get into the playgrounds. And that's one of the reasons I wanted to have this as a day-long thing, so we can use the playgrounds to make it more sense. So we have a bit of view, and this view, we have to give it a bit of state, and that state needs to be able to be changed. And because a struct cannot generate its own memory, we're going to use this state property to make this variable that we can change. But if this view needs to pass that information down to another view, we have another state for that, and that's at binding. And so from the call site, what this looks like is I have a view, right? And it has a little bit of state that it's managing. and it wants to pass it down to a child, basically we use this $sign. And the reason we use the $sign is because we don't want to pass down what do I want to call this? We don't want to pass down the actual state. We want to pass down the value that the state is holding, because our child could now change that state. And when our child changes that state, because this is reactive, our whole UI will update automatically. And we don't have to worry about, you know, going back to all the views that are using this state and tell them all to re-render themselves or any of that. No, this is all taken care of us, right? The state is managed for us through SwiftUI. So we have a state property that has a variable that it wants to change, should it show details or not, and it wants to pass that down to a child, and it does that by passing the $sign of the variable down to the child. And then when the child gets it, it's going to use @binding to get a hold of that piece of data. And then that child can go ahead and manipulate that. And when it does, the framework will re-render all the views and only the views that are using that bit of data. So what's really nice about this is that your UI is no longer a sequence of events. It's just going to react to a state. Now, @binding is a first-class reference type. It's great for reusability and use the $sign to derive from the source. Now, it doesn't just bind to @state. It can bind to observable object and other bindings when you get deeper into that. So when do you use all these different pieces? And when we get into the code labs, it's all going to make a lot more sense. But the way you basically start thinking about it is, what am I displaying? Is it a value type, a struct, or is it an object, right? So if you're working with CoreData, CoreData is definitely an object, right? If you're working with an int or a double or any other type of value type, then yeah, it's a value type. But any class, CoreData, any object that you own, objects that you probably have legacy, legacy ways of getting to, those are probably all the objects, right? So a lot of times for legacy stuff, you're going to walk down this path. But say we have an int, so that's a value type. And then how's the data going to be used? If it's read and write, then you got to ask, who owns the data, right? If it's the view that's going to own the data, use @state. If it's being built outside the current view, you're going to pass it in with binding, right? That's if it's read-write. Now, if it's read-only, that's just a regular property, right? We don't have to worry about that. The only reason we have to worry about doing this line instead of this line is because when you build a struct, that piece of memory in the system on the stack, or actually could be in the heap, but think about it on the stack, we can't change that piece of data anymore. So if we have a variable in there that we're trying to change, Swift 5.1 had to come up with a whole new way to hold that piece of memory. And that's why they came up with @state. So now a magical thing happens when you build a struct, which normally cannot change its memory. You can actually have memory in there that can be read and written. Before we had @state, we just had regular properties. So that's how you use @state and @binding. You have a struct. Thanks for the link. So, so if you have a value type and you're reading and writing to it, you just ask yourself, does my view own this? If your view owns it, it's @state private private at state. And if another view is going to pass it down to you, binding. Okay. So that explains binding. Now, what if you have CoreData, right? Well, at that point, what you have to do is you have to say, how does the view receive the object, right? That's how you really distinguish which one you're going to use, right? How does the view receive the object, right? If it's going to receive it as a parameter, it's going to go to, you're going to use @observable object, right? So if it's being passed in as a parameter, you have to use @observable object, and you think to yourself, why? The reason is when SwiftUI builds a view, it can destroy it, say, 50 billion times a second. Well, if it's destroying that view 50 billion times a second, you want to definitely be sending in your objects as a parameter, right? Because if that view is disappearing 50 billion times a second, you don't want to be creating your data object in that view, right? Just pass as a parameter and use observed object, right? Now you think to yourself, but what if the view that I'm creating is gonna need to create that object? Well, you know, that data, it's gotta live in that view. I can't pass it in. And you're telling me that SwiftUI is gonna destroy this view 50 billion times a second. Well, it takes me 10 days to make this data object that the view is gonna create. That's never gonna work. Well, as of SwiftUI 5.2, we can now have a @state object. And what happens is with @state object, when you create this piece of data, @state object, every time that view is being re-rendered 50 billion times a second, it won't recreate your data. So we can now create our data inside the Swift view, even knowing that SwiftUI can destroy that view. So if you're just passing it in, observed object. If you have to create it, you have to use this, because if you try to create the object inside the view, it's bad news. Now, also, sometimes what you have multiple levels of views. And so you kind of scratch your head and you go, wait a minute, does that mean that if I'm passing it in from my one view into its children view, into its children's view, into its children's view, into its children's view, I have to keep passing down this observable object all the way down? And the answer is yes, you have to do that, unless you want to use an observable environment object. If you use an environment object, what happens is all the views that are children of the view that you made the environment object from will actually be able to see that object. So it gets around the issue of having to do that. Actually, have a slide way back. I actually go through this one more time. It actually looks like this. So instead of having to send down your view all the way down with the environment object, you can just send it to the two things. Okay, so now we're gonna go to the playgrounds and we're gonna go through how this stuff works so you get a much better idea of what I've been rambling about. So for here, what we want to do is want to close all this. And we're going to go to state management. And I don't believe there's any UI. Oh, do I have any UIs in state management? Let's see here. Okay, so this is my state management. Oh, I am bringing up views. So we'll look at the view. We'll look at the views in this one. And we'll code in the other one. Okay, state management. Let's go ahead and run this guy. Make him live. He is live. Should see UI come up. Excellent. All right. Now, I wrote a bunch of stuff about the stack and the heap and how memory is allocated and all this other stuff. But instead of going through all that, I'm just basically going to say that in Swift, when you make a struct, it's basically immutable. And that's the beautiful thing about protocol-oriented programming, right? You're going to make a struct and you're going to pass that struct around, and it's going to make copies of that. And you know that as it's making copies of that thing, nothing's going to change on you because, you know, structs are basically, when they're allocated, you can't change anything in there. So then you think to yourself, okay, well, that's a problem because my views have state. So in Swift 5.1, they decided to make this at state property wrapper. And we went through earlier this morning about how property wrappers allow you to get to a variable and do certain things with those variables at time of initiation and when you're changing them. So this will be recorded and you can go back and read that section on the property wrappers. So we have a property wrapper on this guy. And basically, definitely want to mark it private. And when this property wrapper changes, the entire view is going to change, right? So we have a VStack here. And the first part of the VStack is just a view that has a button that we can increment this state. And because this is reactive, when we change this, this text is going to change. And anytime any child changes this value, this text will be updated. And therefore, I never again have to worry about keeping my data and my views in sync with each other. So if I click this button, you see my state changes. I don't have to do anything to update it. Now, I have another view here that I want to use. But that view, I really want to use the same state that, you know, my current view is using, right? So my current view is using this state. And I don't want this guy to have a new state, so I need to pass it. You know what? I know how to do that. That's at binding. And I know I don't want to send in the rat value. I want to actually send in the value itself. So I'm going to put a $ in here so I can actually reference the actual value and send it to my binding view. So when do you use binding view? You need read and write access to a property that's owned by the parent view. The wrap property is the value, is a value type, right? Sorry. And you don't own the wrap property. So here we have the binding, and I'm passing it in, and I get to alter it. Now, altering this will not only change my view, anything in my view that was using this, but it will also alter any other views that are using it. So here, if I click on this guy, all right, I'm clicking on this button, which is changing this view, this variable that was sent in from my parent, and it's changing my parent state. In fact, if any other views were using that, it would use it. It would update the state. So those are pretty simple, right? If your view needs it, if your view needs a bit of data, you just private state, right? Now, we have a bit of state up here, right? we have a class up here, and this class has a bit of state. And so when we instantiate it, when we instantiate this class, it has a value. Now, there's something really interesting about this class. It's an observable object. And that observable object means that SwiftUI will keep an eye on it. And anytime this observable object has something that it's publishing and that published value changes, anything that is using this bit of data will re-render itself. Okay, great. So I know that this data provider is an observable object and it's publishing its current value. Okay. Now, here, I'm instantiating this outside of the view. So we have a system data provider. Now, my machine is really old. So when I go to take this current value and add it to 7, it actually goes and runs TensorFlow for 15 days and then uses NORAD's supercomputers to calculate that this current view equals 7 has to be done, and that goes back into TensorFlow for 50 days. And so this operation of saying this current view to 7 could take a couple lifetimes. Okay. So we instantiate it, runs forever, it comes back, and we have our data provider. If we go and we look at our state-owned view 1, this only works with iOS 14 and above. What we have here is I am calling my state, I am instantiating this object. We are not using, right? We are not using the system provided one. We're not. We are creating our own version. Well, we know that SwiftUI can come into this view and blow it away 50 billion times per second, and this takes 50 years to build. Not a good situation. So what we're going to do is we're going to put @StateObject here. And that means that as SwiftUI destroys and builds this, it's not going to call this data provider more than once. So once this data is generated, I don't care how much SwiftUI is changing this view, re-rendering it, redoing whatever. We have our data provider and we're not going to go out and rebuild this. That's the importance of state object. And before iOS 14, people were doing this and they get random crashes because SwiftUI was destroying their view and they were trying to build their objects. So this is going to work fine. So if we go look at state data owner view 1. Okay. So this is our state object, right? Let's change this number so we don't get confused that these two are anyway are linked. Okay. Now he's initialized to number 7. He went off and did a whole bunch of TensorFlow and stuff, and he's initialized to 7. If I increment him, he's moving to 8. But as SwiftUI is destroying and rebuilding this view, I'm still able to use my data. Now, what if I need to send that to another view? That's fine. It's just the same way that we were working with @state and @object binding. We get to pass this provider into any subviews. And as SwiftUI is destroying those subviews, it's fine. We're not going to rebuild that, that data provider. So here, this state data user view 1, so this is the owner and this is we're passing in, when we call this guy, we're passing in this provider. So we definitely don't want to recreate him. Passing him in, and now he has access to it and the current, because we, right, here we don't have to use the $. Should have mentioned that. right, so here we don't have to use $, we just pass in the object itself. So passing in the object itself, he can get to the object and call the current view. And here, he's updating the parent's data that is being passed down to the child. So that is the importance of @state object. Now, what if you have CoreData or you have your own data and you just want to pass it in? That's where observable object comes in, right? I own this data. This is something I manage. I just want SwiftUI to use it. And because, you know what, I manage it, I can make this guy, I can make him conform to being an observable object and put a publisher on it, right? So when this guy changes, this view will be re-rendered. CoreData works with Combine and is a publisher. So anytime my CoreData changes, it automatically updates my UI. It's amazing. In fact, all my code I start with CoreData. I make it a publisher through Combine. I hook that up to my view model, and then I build my view. I can build complex apps in a matter of hours. It's the whole point of this. So I have my little CoreData, whatever. I have my provider. I own it. I give it to SwiftUI, and SwiftUI can now start using it. And anytime CoreData or whatever changes that data, my view re-renders itself. So here I have my state, my system provided data, right? Now, I didn't instantiate it. The system provides this. And again, I can change the value. As I'm changing the value in my data, I'm changing my CoreData objects. It's Combine is publishing that back to my view, and my view is updating. What if I wanted to use that in two views, right? There's no reason for me to pass this down to another view as a child view, right? Because my child view can just get that provider, right? I mean, you just go to the system and get that provider. I don't need to pass it down. So here, this view is, again, going to use the same observable object. And since they're bound, it's talking to the same piece of data. It's talking to the same CoreData. No matter who's talking to that data source, all views that are using that data are getting updated. And that really is the power of NVVM or NVI, depending on if you have a channel or a reducer with a unified state. So now we have talked about @state, @binding, @observable object. There's some more stuff that was added to iOS 14, which is this app storage. And the way the app storage works is it holds the value through through restarts. So that's really useful. If I click this login button, this value will survive in user defaults over restarts. So, I mean, we could have done this already, but again, we're talking about speed, and just by having a property wrapper, it's going to really help us out. And not only do we have something for app storage, but we also have something for scene storage. Unfortunately, because we're in a playground and it's one scene, I need to work on this some more. I couldn't quite get the scene storage to work properly in a playground, but yeah, I think that's just, I need to work that out. So, okay, so that's app storage, and then scene storage. The last thing I want to talk about really quickly is that thing I was saying about the environment object. The way it works is instead of passing down a piece of data through all of your views, you can actually just stick it in the environment and then pull it out of the environment. So what we will notice is that right here, I have an observable object that is a publisher of an item. And then I have a struct that has a observable object in it of that type. And now, anytime I want to use this order in any of my children views, I don't have to pass it down, pass it down, pass it down, pass it down. I can just ask the environment to give me this, this order and just use it that way. So it's just a convenience so that I don't have to pass down you know, this class, this data structure, this thing that I built all the way through my child views. So that's environment object, scene storage, app storage, observable object, state object, binding, state. So for the next 15 minutes, I think I'm just going to have you guys play around with this, gosh, I keep wanting to say collabs, this playground to get an idea of how these various states work. And I think there's some questions, and this will be a perfect time to just experiment, you know, and just play with this playground to figure out how all the various pieces work. And so, okay, I think it would be good to take a 15-minute break. So I think we're looking at, yeah, how about just a 15-minute break, and then we'll come back and we'll go through combine. This is interesting because I went through that a lot faster than I thought I was going to. So let's think about this for a second. So let's come back in 15 minutes. Then we're going to go through combine, the playgrounds. And then what I think I can do is just show you how the code works for the shared bike app. And then I think we're good, because the rest of the time you guys, I was hoping that you guys were just gonna play with the shared bike app. So yeah, we're making good time, and definitely, yeah, this makes sense. So how about coming back in 15 minutes and we'll go through how combine works. How's that sound? People happy with that? Okay, so we'll be back in 15 minutes and we're gonna go through combine. I think we're gonna be done before lunch. So we'll see how it goes. Okay, all right, back in 15. That is Mountain Time 15, not Pacific Time 15. Just gotta keep that straight. All right, thanks you guys. Okay, I have to do some housekeeping really quick. So one of the things I forgot to mention is the playgrounds for the combined section were gotten from an external author, and I gave him credit on the 360 site. So if you look at so on the GitHub page. We are now going to talk about the Combine framework, and we're going to go through a series of slides. We're going to explain publishers, subjects, operators, subscribers, but we're going to be using these playgrounds. And so, let's see here. So I want to give credit to the author for providing the playgrounds that we're going to go through. And I'm all for code reviews, all for using GitHub as much as possible to leverage on our projects. So, oh, you're right. Okay, yes, I will wait until 11:50. All right, so I will not say anything important for 3 minutes, but there are, I think, some housekeeping stuff that I was thinking about. So knowing that we have only one section left, what I'm thinking right now is, and we can talk about this again after this section, but what I'm thinking now is I'm okay if we kind of skip lunch and we take a 15-minute break after this section. And this is what I'm thinking. We can talk about this after the section, but I'm thinking something like 15-minute break after this section where you guys can go grab some food if it's lunchtime or whatever. And then we come back and I basically just show you how the shared bike app is put together, MVVM architecture using Combine and SwiftUI. And then you can work on it then, or I'm going to be on the Slack channel for the rest of the day answering questions, and you guys are free to just either work on the code at that point or work on it later, or we can talk about that after this section. But it just seems to me like I can free up a lot of people's day by just getting through this section and then having another really quick break and then going through the source for the shared bike app and then letting people go on to other workshops or work on it, and then I'll be in the Slack channel. So kind of what I'm thinking now. But we can discuss that after this section. So just one more minute before we start, and then we'll get back into Combine. All right, just one more minute till we start. But I was just wondering, like, are you guys following me pretty well? I didn't know the quality of what I was saying, and the various levels of the people. So excellent, cool. I think it's interesting that at WWDC, people really talked a lot about SwiftUI, but then afterwards, people really started talking about Combine. And I think, it's interesting that at this WWDC, they had a talk on state management, which went through all of the at state, at binding, at state object, at observable object. They went through all that, but they didn't touch Combine that much. And even at the first WWDC where they brought Combine out, they just had like some minor sections on it, and it's just such a huge piece of how SwiftUI works. So found that interesting. All right, so let's begin. So for this next section, we're going to get deep into how Combine works. And Combine is a publish subscribe system like Rx Java, Rx Swift, things of that nature. So it's a reactive framework that really allows us to build MVVM. So it really helps us build MVVM. And for me, the view model is the keystone to my entire project. So, and you know, the view model relies heavily on Combine. And it's interesting that, you know, it is such a huge piece, and yet it doesn't get, I think, the recognition it deserves. So let's jump into the slides. Okay. So the Combine framework, it is the declarative framework for processing events and values over time, right? It's a pub sub system. This link provided using Combine, it is an entire free book that covers all of the details of Combine. I've never seen anything so well detailing Combine as this link. So if you have questions about how Combine works and the various pieces of it, I really encourage you to check out using Combine. Why is it called Combine? The reason it's called Combine is we have publishers and subscribers. Thanks for the Slack update. We have publishers and subscribers, but to get from a publisher to a subscriber, we need to combine a whole bunch of operations between those two to be able to get from where we are to where we need to be. And so we're going to combine a whole bunch of operators to be able to do that. This is really typical of having lots of operators between your publishers and receivers to get your error types and your data correct. So publishers are going to publish a sequence of events over time, and subscribers are going to subscribe to them. But this is very different than Rx Java or Rx Swift, because the subscriber is going to do the flow control. We don't have to worry about the overloading of the subscriber, right? There's a problem with back pressure when you do reactive programming that Combine doesn't have an issue with, because they thought about the back pressure when they were building the system. So I encourage you, if you're on Rx, anything, Rx Swift, any other type of system, I would encourage you to move over to Combine, because you're going to find that a lot of the issues with the back pressure are taken care of by using the Combine framework. And over time, just like they fixed the @state object wrapper with SwiftUI, we noticed that Combine is going to be worked on. So the problem with most reactive programming languages is back pressure. If I have a publisher and he's publishing, right, and I'm a subscriber and I'm listening, what if I'm a subscriber that is on a 7070 Intel chip from the 1980s, right? And my clock hertz is 1 hertz, right? So basically I'm going on a modem or something, right? And this publisher's throttling a ton of data on me. I have to have a whole bunch of different techniques to be able to handle that flow control. Well, with Combine, because the subscriber is controlling the flow control, we don't have problems with back pressure. And I'm pretty sure other people in Slack can give you a better explanation of back pressure. But the beautiful thing is, in the Combine framework, we don't have to worry about it. So the Combine framework is made out of publishers, operators, and subscribers. When we're working with a publisher, when we look at the structure of a publisher, it has an output and a failure type. So it has an output type and a failure type. When we look at the subscriber, it has an input type and a failure type. And no matter what publisher you're working with and what subscriber you're working with, those two have to match. If they don't match, they're not going to talk. The failure types are going to say this is a failure, huge failure. So then we have to scratch our heads and we say, okay, how are we going to get this publisher and this subscriber to talk when their output and their input and their failure types are different? Well, that's where operators come in. Operators take one type of input and map it to a different type of output. And they take one type of failure input and map it to a different type of failure output. Operators are really important. But Apple did something really clever with operators. They made them familiar. So even knowing these operators are, very, we're working in a pub sub system, they did something really clever with these operators to make them really familiar, and we're going to get into that. So first I want to talk about why we don't have to worry about the flow control where the publisher is going to, slam the subscriber and we have to worry about back pressure because the pattern of how Combine works. So you have a publisher, and the publisher could be it's just publishing, and if you're not subscribing, you're just going to miss what it's publishing. So if you think about, if you know what a cold flow is or a hot stream, this publisher would be a hot stream. So we have this publisher and it's publishing. The subscriber at that point will say, I want to subscribe, right? And then the publisher will send a receive on that subscription. And once it sends that receive, then the subscriber, it doesn't get completely inundated with information. It can now ask the request, right? So it requests a number of values, and then that publisher can send that number of values or less if it doesn't have it. And then the publisher could send a completion, right? And because we have the subscriber attaching and then requesting the values, the subscribers control in more control than normal, and it can handle the publisher. So we've been talking about publishers and subscribers. At WWDC, they walk through a magic trick. And if you watch that video, he does a really good job. It's the WWDC, not this year's, last year's, the Combine in Practice video. He goes through this, this example. I'm gonna go through it, and I hope I do a good job explaining it. But you can also go back and watch that video and get a better understanding of what's going on, and then come back and watch this video again to get a better understanding of what's going on. So between the two of us, I think we're gonna get, you're gonna get a good understanding of how this works. And someone, thank you so much for putting the video for the Combine video. So what happens is Notification Center is a publisher, right? So here we're going to ask Notification Center for its default publisher, and we're going to ask it to send down a new trick, right? So this guy is going to return to us a publisher. Now this publisher on this next map, we can see that this publisher, it is a notification. The type of what it's sending is a notification, and it can never fail, right? That's its error type. So whenever we're talking about a publisher, we have to key in what type is it, is its output, and what failure does it have? Like that has to be in every thought we have. That's the most important thing. So this guy, his type is a notification center, a notification, and it can never fail. Well, what do we want to do? We want to give this to SwiftUI. Well, if we want to give this to SwiftUI, you got to give SwiftUI some text. And you better not, I better not fail, right? Because if I go give SwiftUI some text, right? So it's like text, quote, open paren, some text, I can't put in null there, right? I can't do it, I can't fail. So whatever I got to do, I got to make sure that my failure type is never. So if I look at what I'm getting, I got a notification that never fails. That's pretty close to what I want, except for this notification needs to be a string. Okay, I'm really far from what I want because I have to turn this notification into a string. Darn. Okay, let me see what I can do. All right, I got this publisher. What can I do on it? Well, we said that there's these operators, and these operators can operate on my publisher and give me a subscriber. These operators, what are these? Wow, these operators look a lot like what I can do to a collection. I got map, I got merge, I got drop, I got reduce, I got collect, I got contains. Wow. Now I wonder if I treat this publisher as just a data structure, I wonder if I could get away with that. If the guys at Apple were really smart, they would let me do that. I have no idea how a publisher works, but I know how map works. And what a map does is it takes my collection and acts on every item in my collection on the way that map works. So let me go ahead and I'm going to map that notification. Oh, sorry, I meant to highlight it. I'm going to take this notification and I'm going to return the data inside of it. I'm going to use the map function to do that. So I'm going to go into the notification center and I'm going to get my data. All right. Okay, so now I got some data that never fails. This data, that's kind of far from where I want. I need a string. So let's go back to my operators. What can I use here? Well, turns out flat map takes a whole bunch of that type of data structure and then flattens it to just that one type, right? So here what I need to do is I need to decode that data. Now I know when I decode it, I can get an error. And when I get an error, that's going to really mess me up. So what I really need to do is decode it and hold on to some sort of publisher so I can get back to a publisher, because I need to be on a publisher so I can publish that data to SwiftUI. So flat map, what it allows me to do is take my data and decode it by the fact that it's going to take a bunch of publishers and flatten them to just one publisher. And the reason we have to do this is because I don't want to lose my ability to be a publisher with an error, right? So what I have to do is I'm going to take my data and I'm going to try to decode it. And if I can't, I'm going to replace it with a publisher that's a placeholder while I'm still holding on to my original publisher. I don't want to let go of my old publisher, and I want to have a placeholder publisher so the next time he publishes, I can come back through this, this series of events. So what happens is that's a perfect use of flat map. I'll get into flat map in the I keep wanting to say code labs, playgrounds. We're gonna actually walk through what flat map does. So I get my data, my map went into my notification center and got my data. Super cool function here that Apple provides that you can do on a publisher, which is just use JSON to decode it, right? So now I have my data, right? And I'm gonna try to decode it, right? If I can decode it, right, then what I just want to do is publish it. And that's where this just comes in. What this just is it's a publisher that's going to publish this one piece of data. If it can decode it, right? If it can decode it, it's going to publish it. If it can't, it's going to catch that error and it's going to publish this placeholder. What comes out of FlatMap, so FlatMap takes a series of publishers, right? Sorry. FlatMap takes a series of data structures of whatever, publishers, whatever, flattens them and gives you back the same result. So if this was an array of numbers, FlatMap would take those array of numbers and make only one array of those numbers and then return that. So FlatMap does not change the type, the overall type of what it gets. It just takes a whole bunch of them and returns only one of those types. So it's going to take a publisher and it's going to exude a publisher. Just is a publisher. Just takes data and just publishes it. If we can decode it, right, this decode, this JSON decoder will decode our data and then we're going to publish it. If we can't, we're going to publish a placeholder. So FlatMap is going to hold on to the previous publisher and move forward with a placeholder or the actual thing we decoded. Okay, so now we take that publisher and we're going to look inside that data structure, this data, that's decoded data. So we're going to look inside this JSON. This JSON is a tree. We're going to walk down that tree and we're looking for the name inside of this thing. This magic trick, I should have put the data structure up there for it. It has this data in there called name. And so we're going to go in there and we're going to talk to this publisher and we're going to get the name. And now I want to give it to SwiftUI, but I can't give it to SwiftUI because I'm on a background thread. So what I want to do is I want to move it to the main loop and then I want to be able to publish. So what does that look like? One more time. We took something that came out of Notification Center that could never fail. And we have to give it to SwiftUI, so we need it on the main thread, a string that never fails. Okay, we have to go through a whole bunch of operators. We use map to run a closure, right? To run a closure on our notification to get the data. So now we have data that never fails. Then we used FlatMap, right? So what FlatMap did is it took the magic trick and it decoded it, right? If it caught an error, it published a placeholder. If it was able to decode it, it published a string that could never fail. We went into this decoded JSON and got the string we needed. And then we published on the main thread a string that will never fail. And that's exactly what SwiftUI needed, right? So by using, and we're going to get deep into operators when we go through the playgrounds, but this is just so that we can start thinking about how combine works before we actually start learning how combine works. In no way do I expect you to understand how combine works with what I just said. This is just to get the terminology up, right? So if you didn't follow that, it's kind of okay because we're going to get deeper into this stuff. Now, a lot of times when you're working with publishers, you're going to see this thing called ease to any publisher. And I pulled this slide from Try Swift Italy, I think, one of the presenters, I think there was, put this slide up that I thought was just really good, explaining why we need to do that. Because as you call the operators on a publisher, they add their own types to the publish. So unfortunately, when you get your data, it's wrapped in URL. And then when you unmap it, it's mapped with this. And then when you reduce the error, you get this whole thing. So a lot of times you'll see this erase to publisher. You don't really have to know what it's doing. Just know that all these operators are adding a whole bunch of like garbage onto the type. And we just want to erase it to a publisher. I wouldn't worry about how it works. Just know that it's doing what you need it to do. All right. So the beautiful thing as we get deeper into this is you're going to realize you can stop thinking about the publishers as publishers and just think of them as any collection class that we've already worked with when you're working with these operators. And that's why they're amazing. And Apple is writing more and more operators to make our lives much easier to work with publishers and subscribers. So there's 3 rules of subscribing, right? The subscriber will call for a subscription once and only once. The subscriber will receive 0 or more values. And the publisher will call one final optional completion when it's done. So the protocol for a subscriber looks like this: has an input with a failure, and it calls receive on a subscription, and then it gets its values, and then the receiver calls the completion when either it failed or when it was done. So we have 2 really nice built-in subscribers to make it very, very easy for us to work with publishers. We have assign on, which takes a key path and puts it right into our object. So it looks into this object and it finds is enabled inside this object, and it assigns the value from this publisher. So the publisher is sending this is enabled, and we're going right into our object and we're setting this, and then SwiftUI is probably observing this and it updates the view. The other really nice subscriber we have is sync. And what sync does, it gives you the value that the publisher is sending, and then you can go ahead and just do whatever you want with that value. So those are 2 really nice subscribers that are built into Combine for us. We also have a subscriber, and the subscriber is used a lot in SwiftUI because what you want to be able to do is send information really easily. And that's what a subscriber allows you to do. Basically, I'm talking about subject, sorry. So, scratch that. Let me start again. So yeah, so here's we're making a subscriber, and the subscriber here is just using sync, and then it's using, sorry, okay. What I meant to say is subjects are used a lot in SwiftUI, and it behaves both like a publisher and a subscriber, right? So, gosh, I was off by 1 slide. So subjects have, and they can broadcast to multiple subscribers. So what they look like is you can send from a subject a value, right? And in the playgrounds, we're going to get deeper into how you can inject values into a stream by just calling send. So you have a subject, you have a publisher, and you have a subject that's going to be a subscriber to that publisher. So now you are now in the middle of that stream, and what you can do is you can inject values into that publisher by calling send. Because subjects act like a publisher, like a subscriber and a publisher. So when the publisher is publishing, the subject will subscribe to it. So it's acting like a subscriber. And then it can send values. So it's now a publisher for that publisher to the down path subscribers. So we have two really nice subjects we can use. We have a pass-through subject, which is just going to send the information that the publisher is providing for it. It's just going to send it along the stream, right? And then we have a current value subject, right? So if you think about, if you know about cold streams and cold flows and hot streams, if you know that, so this is a hot stream. So pass-through subject is a hot stream. If you don't know that stuff, don't worry about it. Just nomenclature, terminology. So this does not keep its last value, right? It's a flow of data that just passes through the subject. If you want to hold on to the last value that was sent down the stream, then you use the current value subject. And again, I have playgrounds that show how all this works. Okay. And we have schedulers like the onReceive that allow you to publish on different threads. And we're going to get into, we have a playground for schedulers also. And both of them are really useful for SwiftUI. Now, excellent. Okay. All right. Do okay. So, okay. So this is, again, back to the WWDC talk that the link was provided in the Slack channel. Basically, here we have this class that we're building, right? And this is just an example of how pass-through subjects work. We have a class that we're building. And because we are conforming to the bindable object, we have to have a did change, right? That is going to tell the system when things are updated. And so this pass-through subject is the way that our model is going to talk to our view. So when we generate this model, again, it has to be the object binding, because this is data we created, we don't own it. When this model's name changes, this view is updated because this model has a publisher in it, right? So this is an example of using combine inside SwiftUI. And we're going to get deeper into the code labs, playgrounds, and we're going to have examples of how you actually build this. So I think at this point, I really just want to jump into the playgrounds, because slides are just never going to do it justice. But before we get into the playgrounds, I'm actually going to get a grab a drink of water, because this is heavy. So let me go ahead over to the playgrounds. And I'm going to run out and grab a drink of water and come right back, because my throat is really dry and this is going to be a little bit of work. Okay. So I'll give you guys some time to get over to the XCode. And we're going to start with publishers and subscribers. I'm going to leave you with a blank wall for just 1 second. Sorry about that. I should have had my water bottle filled during the last break. But, okay. So I keep saying collabs. Collabs is actually what I do during the day. It's how you run TensorFlow inside a browser. So again, I was just about to say, let's go look at collabs. But playgrounds. I hope you guys all had a chance to bring up XCode back. And we're going to start going through how Combine works by looking at these playgrounds. Now, I don't believe I have any UI work, so I think I can close this guy. Machine's running hot. Okay. So, publishers publish data, subscribers subscribe to data. This is just going to publish 24, right? Just publish. It's a, it's a publisher. Now, since we have a publisher, we can put a subscriber on it, and sync is a subscriber. If we run this, we see that we received the value from the publisher to the subscriber. If we had a sequence of events, this publisher would just be publishing them constantly. Now, we have to make sure our types always match. This type of publisher, it's an int, okay, got that. And it cannot fail, okay. Gotta really remember, this is super important. This sync, what's it need? This value definitely will work with an int, and it's a good thing that it does not error, so this subscriber will be able to take this publisher. So that's good. That's good news. We can work on, we can move on. Now we have a publisher that is sending a sequence of events. And this is really the power of the combined system. The fact that you can just take a data structure and put .publisher at the end of it and make it into a publisher, that's fantastic. So we have a publisher here. What is this? It's going to send an int. I'm assuming it never fails because, well, it's an int. We're going to go ahead and publish, grab that publisher, and we're going to put it into this subscriber, right? And as we get the output from this publisher and put it into the subscriber, we're going to do something here. This publisher, we know for a fact that we can add a number to an int. If this was a string, this would fail, right? We know we can add a number to an int. And I think, yeah, we have an example of that. And after this, you guys can go play with with this collab for hours on end. So we see that we're going to take and add a value to it, print it out, and that's our subscriber. So if we were to run that, and we get our values. Now we have an operator here. This operator looks like the same operator that we would put on any collection class, but it's going to a publisher. So if you were in Xcode and you held down the option click, this would talk to you about how it's a map to a publisher. If you did it on a data structure and did option click, it would tell you how it's an operator on a collection. But it acts very similarly. And we're going to get deeper into that. So if we were to look at this, where we're actually sending in a value, right, that is a string, when we come and run it, and we're running this publisher, sorry, I need to distinguish these two. So if we were to run this, what we would see is publisher S works fine, right? And now I just told you that you can't put in a string and use a value on it. Well, I just did. Well, what happened? Looks like we're using the map function here to map our string to an int, right? So if I actually took this map function out of this publication, we see that the subscriber is going to have issues with it. Well, not only the subscriber is going to have issues with it, but actually our print statement is. So thankfully, we can put this operator on our publisher to get to the right type that we need. And what's really cool is, remember how I was talking about we can take a object and put a value into that object by subscribing to a publisher, right? So here, what we have is we have this property of an int. I'm instantiating the object, and I'm taking the publisher, and I'm using this assign key path to look inside my object, right? To look for this property and assign this value onto this property. So that's kind of cool that it allows us, and on the did set we see as the publisher is sending the values down the channel stream flow, it's being set properly. So the assign operator is pretty amazing. We go and look at subjects. I think that was right. Yeah. Okay. So subjects. Now, when we were talking before, I started talking about subscribers when I meant to talk about subjects. So that's because a subject is a subscriber, but it's also a publisher. And so here we have a pass-through subject. Remember the pass-through subject, it doesn't hold any values. So we have to subscribe to it before we start sending values. Now, this is a publisher on its own. So we can go ahead and subscribe to it, right? It's a publisher on its own, we can go ahead and subscribe to it. But it can also be a subject to a subscriber. And we'll show examples of that also. Here, since this is a publisher, we can go ahead and send words onto it, and the publisher, it'll be published and the subscription will get it, right? So this is a really nice way when you're working in SwiftUI, if you have a stream of information that you need to inject into, or you want to create a new stream, it works. Next, we have this 2 words that are going to be published for us, right? And we're going to, so now once we build this publisher, we can subscribe to it. If we were to reverse the order, we would actually be listening before the publication starts. And so when we send these words, we're going to miss it. So you always want to have your subscriber listening to the publisher before the subscriber is done. But here, because the subscriber is going to tell the publisher that it's ready for a subscription, it's going to, the publisher is at that point going to publish. Now, wow, there's a lot going on here. Sorry. Let me start that again. Okay. We have a publisher here, right? And this publisher is going to publish these 3 words, right? And what's going to happen is we're going to subscribe with this subject, right? Because this subject, because this relay is also a subject, it can listen to this publisher. So that's what's happening here. We build a publisher, right? And then that publisher is being subscribed to by this subject, who is also a publisher. So what happens is when he's subscribing, right, he's going to be printing this sync, right? So this relay is subscribing to this publisher. And so he's not only publishing here, but he's subscribing here. And so what happens is we build this publisher. This subscriber says, okay, I want to subscribe to you, publisher. They establish their subscription, and then he sends the information. And here he's acting as a publisher, and here he's acting as a subscriber. Okay, so that was how the pass-through values work. Now, if we missed the values here, we would get nothing when we subscribe. But if we use the current value subject, it will always hold the last value that was sent to it. And a lot of times that's the only one we really care about, because if you're thinking about like stock information, we just care about the latest price. And here we have, it takes a string that never fails. And because this is a, if you know hot streams and cold flows, this is a cold flow. If you don't, doesn't matter. If you have a cold flow, you know the cold flow always has a value, and because a cold flow always has a value, you must initialize a current value with a value. Now, another way to say that, without bringing in any of those terms, is the current subject, using the current value subject, no matter when you connect to it, it has to give you a value. It has to, right? So therefore, when you build this one, unlike the other subject, you have to give it an initial value, because the current value subject will always have a value. Now, what we're going to do is on this publisher, we're going to treat, at first we're going to treat this guy as a publisher. We're going to send 100 values, right? Okay, where am I? Yes. So we're going to send 100 values. We have a subscription on this guy. So when we run him, we only got the very last value, right? We lost all the other ones because he's only holding the last one. We let them all run out, and then we subscribe afterwards. So here is a bit of code that you guys can uncode, that you can uncomment later, or maybe, yeah, you can uncomment later. And what happens here is we have a pass-through subject, right? So when you subscribe to this guy, you lose everything. And if you use this guy, you will keep the last value. And if you, right, so then you can start playing around with, do I see the value or not, depending on if I use a pass-through subject or if I'm just holding the last value. Okay, so that's that. If you want to say collab, that's that playground you guys can play with. So the next one I want to talk about are subscriptions. All right. So you're going to subscribe to a subscription, you're going to get 0 or more values, and then maybe you're going to get a completion. So we have this subject that is going to act like a publisher. And notice, because it's a pass-through subject, we don't have to initialize it. We have a subject here. Now, what's really cool, if you really want to understand what is happening inside the actual publisher, you can add this event handler. And whenever a receive completion, or receive output, receive completion, or receive cancel happens inside your stream, you will absolutely see it, which is really helpful for debugging. You can also put this .print in here. And when you put the .print in there, it gives you not the individual, but all of the things that are happening. Now that we have our publisher, we're going to go ahead and publish some strings on it and see what happens. So we got a new subscription, so our publisher saw that. And then we're listening to our subject, right? Handle these events, right? The only time that we're going to listen to the subscriber is when we see this subscription received value. When we don't see this message, it's coming from the publisher. When we see this, it's coming from the subscriber. So the publisher is saying new subscription. The publisher is saying receive new value. The subscriber is saying, oh, I got hello. The publisher is, am I saying this wrong? Where is this? Yes. Okay. So right. So the publisher is saying I received a new value, which is happening here. He's receiving a new value. The subscriber is saying, I get that value. The publisher is saying, I received that new value. The subscriber is saying, yes, I received that last value. And then he's sending a cancellation. And then now we have our cancellation. Let's see here. And then I think that is the error. Let's see here. We can sure. No, we're sending the error here. Got it. We're never getting to this point. Now, wow, there's so many collab playgrounds that it's hard to keep track of what's going on in each one. Sorry. So the publisher is sending hello. The publisher is sending hello again. The publisher is sending hello for the last time. And then the publisher is sending a failure. Right? So here we see that the subscription is canceled because, the subscription is canceled after we receive our last event. So this is our last event, and then the subscription is canceled. Now, but if we send an error, right, the subscriber completes the subscription with a failure. So if we don't send the failure rate, we get all the way through to the subscribers being canceled, including our last subscription. If we fail out, then the subscriber is just going to get a failure. So that's how that works. But if you put in print, you also get all these events right? So for me, I actually rather use the print than to have all these event handlers, because anytime an event happens, I can just get it. Subscription, I get a request for unlimited, I receive a value, I receive a value again, I receive a value for last time, and then I receive something went wrong. So yeah, so this print statement is very powerful and very easy to put into your streams. All right, let's talk about cancellation and memory. So how's everyone doing? Are you guys following me? Can we continue, or how's everyone feeling? We have just a couple more playgrounds to go through. Okay. So let's talk about canceling and memory management when we're talking about the combined framework. We have a class here, right? This class inside of it has a initializing function, and it has dinit in it, and a variable, which every time we change the variable, we're going to print out that the variable changed, right? We have a function here, which is emit next value. Now, when it emits the next value, it's going to be emitting on the main thread with whatever the value you're passing in, with just a little bit of a delay. So this emitted value is just going to, on this queue, emit these values, right? So a little while ago, we were talking about the fact that SwiftUI needs to get everything on the main queue. So this is the main queue that SwiftUI would be talking about. If we wanted to send it on, like say we had some other background tasks that we had to work on, we would actually create a different queue for that. And we're going to get deeper into how all that stuff works in a different collab, but I just wanted to point out what's going on here, that we are just, it's just, you can just think of it as we're just emitting values on this subject right here. So this subject, let's see, it is a pass-through subject, right? And so basically we can just pass values to that subject. And when that subject gets those values, it's going to publish it. So here we have an array of numbers, right, that we're going to give to that pass-through publisher, and it's going to publish them after a small amount of time. And what we're also going to do, right, is we have another thread running. So these queues are threads, and I didn't want to make this too complex, but threads are just background processes that run independently of each other, right? So this is one thread, and what it's going to be doing is it's going to be publishing values, right? And we have another devious thread here, and what this guy is going to do is after a certain amount of time, he's going to take our object and destroy it, right? And we're going to see what happens with the combined publisher, right, in the combined framework. What happens to a publisher when it's deallocated, right? Now, one thing we have to point out, the reason that we're going to get into trouble is we have a strong reference to ourselves, so we're building a cycle here. If we didn't have a strong reference to ourselves and we weren't building this, this cycle, this retained cycle, none of this would be an issue, But in this class, right, in this class, when we initialize ourselves, we have a subject here, and this subscriber, right, this subscriber, inside of his, in his subscription, when he's subscribing, he's actually using, inside this closure, he's actually capturing this, this variable that's outside the closure. So he's now generating a strong, he has a retain cycle in here. When we are using this subject, the combined framework, because we're holding on to this value, he's going to keep this subscription around even if this object disappears, right? Because we're making a strong retain cycle here. So let me show you how that works. If we run this, what we notice is our objects come through. I nullify the object, and the object's gone. At this point, we no longer we are telling the system, hey, we're done. Get rid of our object for us, right? So there's a couple things we can do here. If we don't have this strong retain cycle, and we run it again, fingers crossed, it should stop. Okay, great. Look at that, it stopped. I wonder why. Because we nullify the object here, right? This thread dispatching on another thread has nothing to do with this emitter. It's just going to come in underneath it and nullify our object, right? Devious thing, it's going to kill our daemon. So what happens is I'm basically telling the system, hey, I don't want that object around anymore. And the system says, okay, you don't want that object around anymore? I don't see a retain cycle here. So what I'm going to do is I'm going to deallocate this object, and everything is fine. But if we have this retain cycle, now, what happens if we go ahead and cancel our subscription and then nullify our object, right? Now here, the system's going to look at it and say, okay, well, this subject that is holding on to my value has been canceled, so he's out of memory. So when you're going to pull me out of memory, I'm going to nullify and deallocate, right? And so I just wanted to give you, so the person who made these, I want to say collabs, who made these playgrounds wanted to put this in here for us so that we get a really good idea of how important it is to watch out for this. The other thing that I want to point out is if you don't hold on to this cancelable, nothing runs, right? So let me, oh, I want to keep this commented out. Okay, so watch this. Same code, same exact code. When we run it, what happens is when we come out of this initialization, this cancelable, it's cleaned up, it's lost, right? And because it's lost, the subscription, because it's lost after the initialization, the subscription is thrown away, right? We're not, in fact, that's why this cancelable exists, right? The reason that I have this cancelable here is that if I don't hold on to it after the initialization, after this guy's running, like, this subject will say, okay, I'm ready to go. oh, I'm done. I see this end curly braces. Okay, I'm done. Okay, bye-bye, everybody. And so there's another way that we can hold on to cancellables. The system actually has an array of cancellables that you can put your cancelable into, and it'll keep track of it for you, because we can't let this guy disappear, right? Got to keep him around, or your subscription, right? Your subscription will not run, right? Will not run. But if we hold on to our cancelable, subscription will run. So if you're trying to get your subscription to run and it's not going, and you're wondering what happened, it's because you didn't hold on to your cancelable. All right, so let's talk about simple operations. We're only going to do like a couple more, and then we're going to take a break. So we're just going to hopefully everyone's happy. Okay, what I was talking about operations is they work just like you're working on a collection. So I have a publisher. This publisher, I'm going to send it like just to explain really quickly, a map takes a closure. And remember I said, if you have a closure as the last argument in your function, you can move it outside the curly braces. So this would normally be inside this curly braces because this thing actually takes this guy as its argument. Okay, sorry. So this is the argument to map. Every value it's going to take, it's going to add 100 to it, right? Now we have our publisher. We can do the same thing to that by adding this map to this publisher as we did, you know, to this guy, right? So when we run this, all right, let me see here. Run this. So publisher 1 emits 28. We add 100 to it, we get 128, right? So we're just using this map function on the first publisher, and then we're publishing it. On the second publisher, we're adding 100 to it. So the first publisher doesn't have this map value, and the second publisher does have the map value. That's why they're off by 100. But I can just add this map value to my publisher, and they're going to publish the same values. Cool. Filter, we use this all the time in collection classes. We can happily add that to our publishers, right? So here we're only going to filter out anything that's not even, and here we can filter out anything that's under 15, right? And I'll let you guys play with this. Gosh, I want to say hold on. Let you play with this playground, and you can go ahead and put different operators on it and just see what happens when you take operators that you know what happened in collections and add them to publishers. I thought I had way more. Oh, I did. Okay, so I actually have in another playground, I have hundreds of publishers that I took from containers and moved them to publishers, and I didn't move them over here, so they're missing. Because I actually had map, I had flat map, I had a whole bunch of data structures that I went through, and then I did the same thing for publishers and showed that they act exactly the same with each other. I will update this playground to include that. But, sorry about that. I have to fix that. Maybe during the break. So let's talk about another publisher, which is one of my favorite publishers, Combine Latest. It basically takes this publisher and takes their latest values and combines it for us. Now notice that these values are coming from something that doesn't hold its latest value. So this is the guy who's holding the latest values. If we look, first we're going to publish the username, and then we're going to publish a weak password, and then we're going to publish a strong password. It's always going to hold on to the username, always, because we don't publish another one. The first time, it's going to use a crappy password. The second time, it's going to use an awesome password. And it's always, going to combine the two. So if we run this, we notice that the first time with the weak password didn't work. With the strong password, it worked. It kept the username from the last time that we held on to it and just updated the passwords by combining the latest. Love that operator. We also have a merge, which can take publishers and merge them. So we have two publishers. And when we run this, we just merge them, right? So be on the lookout for real cool operators that can combine. Next, we're going to talk about scheduling a little bit. And scheduling is really important because it allows us to do something on the background thread and then move it to the main thread when we want to talk to SwiftUI. So honestly, I'm going to read through this code because I don't remember what it does. There's so many playgrounds here that I lose track. So I'm going to read through the code with you guys, and then it'll remind me of what I'm trying to talk about. Excellent. Okay, so scheduling operators, we're going to dispatch on the main queue and on a background queue. So first, what we're going to do is we're going to set up a semaphore so that as we're talking on different queues, different threads, they're not going to clobber each other. And that way we can see what the different pieces of the code are doing. So we have a subject. You can use it as a publisher or a subscriber. We're going to make a new thread, right? This queue, brand new queue thread. It's going to be our receiving queue. We have our pass-through publisher. Oh, subscriber here. Receive on. Okay, we're going to receive on this queue when this subject is, when this publisher is publishing, it's going to publish on the queue, and then this subscriber, I think I'm saying this right, this subscriber is going to receive, we're publishing on the, we're publishing on the, we're publishing on the main thread and we're receiving on this queue. Okay, so here we go. I have my publisher that I'm going to be sending events on, right? Because it's a subject, it can inject into a stream single values. So these are the single values I'm going to be publishing. I'm going to go ahead and send those one at a time, right? I'm going to publish those on the main thread. But I'm going to receive them on this receiving queue. So I'm making this receiving queue. Now it's all coming back to me. And so I'm going to receive this subject on this receiving queue. All right, so if I were to run that, what happens is I'm receiving on this thread number 8, I'm publishing on the main system and receiving on 8. So that's how you make a queue You can use this for publishing or for subscribing. Here we put it on our subscriber, and then we received on it. So we used the main queue to publish, and we used our subscriber queue to subscribe on. Okay, so now we are going to dispatch. Let me see if I remember this properly. Okay, we're going to emit on different threads. I think it'll be a lot clearer in that example how it works. But first, I want to talk about Foundation and the combined framework, and just point out really quickly that URL sessions and decode objects work really well with the combined framework. So here we have a URL session. Okay. Yeah, I'm gonna look at that link in a second. So we have a URL session here that we're gonna go ahead and get the data for, and we're gonna receive this value. We're gonna print it. We're gonna go get the data out of it, and we're gonna decode it. So a lot of the Foundation has combined built into it. So URL session actually works with combine. Notification center works with combine. Key value bindings and NS object instances work with combine. And then timers also work with combine. All right, we talk about flat map really quick. Okay, so flat map allows you to talk to upstream publishers while generating publishers for the downstream and handling errors. So if we look at a data structure, we can put a compact map right on that data structure, but nice. Thanks you guys for answering questions in the Slack channel. I was going in circles. Okay, so here we have a compact map, and basically a compact map, what it does is it does a map on all your values, except it throws away anything that's null. So we have a compact map on a data structure that's going to look exactly the same as what we do with a publisher. So it's whenever we really think about data structures and publishers, we can think of them a lot of the same ways. So if we ran these two, what we would notice is the data structures and the data structures and the publishers are acting exactly the same. Now we have a publisher. Okay. Now we're going to talk about flat map really quick. We have a publisher that is going to publish 3 numbers, and what flat map is going to do is it's going to take those and it's going to republish them over and over again from the number that was passed to the from 0 to the number that was passed. So here what we see is when we run flat map, the first time it produces a publisher, it emits 1 value. The second time it produces the publisher, it emits 2 values. And the third time it produces a publisher, it emits 3 values, right? Because it's going to publish from this loop the beginning number to the end number. And so what flat map is really good at is handling publishers of publishers. And sometimes you're working with so many publishers, you have to limit it. And there you could use max number of publishers so that the flat map does not get overwhelmed with the publishers. Also, you can switch to the latest publisher because FlatMap is, again, taking a lot of publishers and mapping them down to one publisher. Now, a lot of times when we're working with FlatMap, we need to take the error that we're working with and transform it to another error. So here we have a session error. And when we come in, what we want to do is we want to get the data from that piece of URL. But the data it returns is not the right data that we need, and we can go ahead and just map that into the right type of error so that when we come out to get our result, our subscriber can get to it. And so here you can see we're getting this image off of the web, and we're able to take our data, decode it properly, and then map the errors accordingly so that we're able to get our final result. And going through publishers real quick. Unfortunately, XCode playgrounds don't support running publisher properties. So we're just gonna really quickly talk about how publishers work. So here we have a publisher of this Boolean value that is submit allowed is equal to true. And what happens is when we build our controller, we can now, in our view, look at changes to this value, and our views will be updated anytime that changes. So basically, both for SwiftUI and UIKit, we are able to build a reactive model. All right. One last, every time I say collab, I just want to say playground. And then I'm going to read your comments on Slack and get my head straight about what was happening with that subscriber and that publisher during the break. And then we're going to come back and I'm going to actually show you how the bike code is set up for an MVVM architecture to work with a data source fixed into Combine. But first, we have to talk about the fact that Combine also gives you futures and promises. You can think of a future as a one-off publisher. And this is really good when you have a callback, because if you don't use a future and you try to use callbacks, you get into callback hell. And so instead of getting into callback hell, what we're going to do is we're going to use a future and a promise. A future is a promise that's going to happen in the future. So promises and futures go hand in hand. We have an array of users with IDs. Now, if we ask this array of users for one of our users with the correct ID, then it's going to publish to us the correct thing. If it can't find it, it's going to give us an error. So here we're going to fetch the user, and the user takes two variables, the ID and then the completion, right? The completion that the fetch user needs is going to be our promise, right? So here, what happens is we need a user, we need this future to give us a user that has the right error, right? Again, publishers, subscribers, they all have to match up. And so when we go to build this result, we are going to first see if we can build a user. If we can, we're going to complete with success. If we can't, we're going to complete with failure. So this is all we need to be able to build our published user. So now we're going to go ahead and we're going to call our fetch user, and we're going to send in our IDs. So the first time we send in our ID, we'll see that the user does actually exist. And the second time he exists, but we have no user 5, so we're going to get an error, which is exactly what we want, because we're going to map that user and we're going to get the name of that user. And if we can't get that user, then we're going to say we have an error. If we can get the name of that user, then we're going to go ahead and print it out through the subscriber, right? So we all understand how this works, right? Because this is just how subscribers and publishers work. But what's unique here is instead of doing a callback, we're just going to say that when you call this publisher, we're going to use flat map to generate our future, our publisher, right? Flat map can take publishers and generate publishers. So this is the closure that the flat map is going to use to build its publisher. And we're going to take our ID, right? And we're going to return a future, which is a one-shot publisher. And we're going to make a promise, right? We're going to call the fetch user, the first, we're going to give it the ID, and then we're going to give it the closure it needs for the publisher. So here, if we are able to get an ID, then our case is success, and we go ahead and use that promise. But if we can't, then we use a failure promise. Now, the beautiful thing about, and then we go ahead and we return that future, and then the system uses that future, which is a publisher, and produces the output, right? So it basically comes in here and says, can I find that user? If I can find that user, then it's calling this fetch user. He's saying, if I can find that user, then I'm going to complete with a success. If I can't, I'm going to complete with failure. So when we call this guy, he's going to either return a result, which is the success with the right user, or the failure. So, and good thing this is in a collab, because my brain's fried, and you guys can actually go play with this. But one of the things you could do is replace this with a callback of a callback of a callback. So what you could do is you could just have a flat map which produces a future, which is a publisher, and you can stack these flat maps one after another. Instead of going into callback hell, you just keep calling your flat map, and you're able to walk down the calls, the published call stack, and get the data you need without going into callback hell. So anytime you're thinking about using callbacks, definitely want to start looking at futures and promises. And I know I probably made this a lot more complex than it is. Basically, yeah, you're just using this promise with this function to generate the result. Put that into the promise and then give that back to the subscribers. Okay, we're on a break time, but first I just wanted to point out one last time, if you're trying to figure out what's happening in your stream, which I should have been doing when on the previous one, you can always attach the handle events to it, or you could just tell it to print it. So you can get really detailed results when you're trying to debug your publishers and your subscribers. Okay, with that, I think I'm starting to lose my voice, but wow. Okay, what I would like to do, if you guys are because I think I'm losing my voice. What I'd like to do is take a 15-minute break, and then come back and show you how the shared bike app is MVVM and how combine is used with SwiftUI to make this shared bike app work. And then I'm probably going to drop out of the session and just be on Slack, because I think if you ask me questions on the live stream, my voice might have given out. So let's take a 15-minute break. Let me get composed. Not Jetpack composed, but human composed. And we'll walk through the shared model. And there you'll see combine, and you'll see the on receive, SwiftUI getting values and stuff like that. So I will be back in roughly 15 minutes. Get a glass of water, and then we're going to talk. We're going to run the shared bike app, show you how the map works, where the code is, and then I'm going to let you guys run through. Okay, back in 15. Are people happy to go? Ready to go? Okay, so basically, I think I just had a kind of like when I was looking for the how to add Swift packages to Xcode, had a mind skip. So what I'm going to do for that one combine example, I'm going to rewrite it, and I'm going to do a detailed explanation of how all those pieces work, so that it'll make complete sense. Who's publishing on what thread? Yeah, I just got turned around on that, but definitely with the Slack comments, yeah, we got it. So if you look at the GitHub repository, probably in an hour, you do another pull, you will see gosh, I keep wanting to say collab. That playground will be updated with a detailed explanation of what's happening in the various threads. So what I'd like to do now is finish up with what is the core piece of this talk, right? I mean, we've been talking for hours on end now, and the only thing I really wanted to say is, how do you use combine with SwiftUI? And so if we go back to the slides real quick, this is like the key, right? That the fact that we can now take a model and we could bind it to our view allows us to do an MVVM architecture. And yeah, thanks for reminding me about the samples. Appreciate you guys. If we look at the architecture, this is so important, this slide right here, right? If we get the architecture wrong, we're just making a nightmare for ourselves. If we don't know what architecture we're starting out with, we don't even know what our file system's going to look like, right? We don't know where to put our code. So being able to look at this picture and go, okay, am I going MVI? Am I going MVVM? Is really going to help us determine the path that our application is going to take, and ultimately the success, if we're going to have success or failure. So when we look at this, we know that we're probably going to use CoreData for our database. But if you go to the latest version of Xcode, they don't allow you to automatically bring in CoreData like they used to. CoreData has been around since the very first iOS development environment was ever created. It's wonderful technology. I use it every day, and I still think it's amazing, but it could be up for an update. but I'm not worried. I'm going to keep using CoreData because I think whatever they're coming out with, they're going to give us a tool for translation. So I think it's okay that you know, we'll keep working with CoreData, even knowing I did not even show you guys how easy it is to use CoreData with Combine. Combine is designed for CoreData, and CoreData is designed for Combine. It's, you know, every single project I use, first thing I do is I set up CoreData and then use Combine with that. The reason I didn't is because I wanted to make the point that whatever technology is coming out after CoreData, we should move to, because it's probably what Apple is intending for us to use, which, you know, will probably integrate even better with SwiftUI. And that's why I didn't mention CoreData this entire time, even though I'm probably its biggest fan. So even in the project that we're going to talk about right now, I could have easily used CoreData, but I didn't. I just hit a website. So this view model is probably the most important thing that we're going to design. This view model in both MVVM and MVI is the core of the system. It allows the data to talk to our views, right? So if you're doing MVI, your intents are going to go through a channel, and the reducer is going to make a new view. That new view, that new immutable view is going to live in your view model. If you're doing MVVM, then what happens is the view model is it's going to use the combined framework and publishers and subscribers and all the other at data and all the other publishers to bind itself to the view. So whatever the state is of the view model, it's just exactly what the view is. You know, we don't have to update our views, right? Because we're binding the view to the view model. And the view model is talking through Combine to CoreData. So those two are in sync. There's no synchronization issues here, right? We don't, a lot of problems that we normally have to worry about are just going to absolutely disappear. So let's look at an example of a shared bike app that kind of does all that. All right, hopefully, okay. So we start out with XCode, and we have to figure out what do we want to build. And for me, I do cancer research at a biotech. So obviously the most important thing to me in the whole world is shared bikes. And the reason for that is, like, you can go to the doctor and he can give you whatever pills that he can possibly give to make people feel better. But at the end of the day, prevention is really the key. So much better to be healthy than to have to use any medicine that I'm designing. With that, shared bikes are the most important thing that we could be working on. And if we look at Xcode, the first thing we have to do is figure out what data are we using. I could easily go with CoreData. I could go with a lot of different data sources. But I just decided I wanted to keep this as simple as possible, and you guys could easily add CoreData to this yourselves. But I just wanted to give you a skeleton that you could build on. So I wanted to keep it really simple. Our data is actually just coming from the web. And if you look at the bike API in there, you'll basically see that we're going to go talk to the global bike API, and we're going to get where all the bikes are and how many bikes are at each station. And we're going to demo that. Let me demo that real quick so you know what we're building. Now, all of the code that is inside this bike share API, we didn't write any of that, right? So all this code, we don't write any of that. That's all generated for us from the API itself. Okay. So we have this little application here. The only reason that this screen is here is because I had a hard time getting it to run in the playgrounds. So ignore that. The only reason this screen is here is because I wanted to show you how navigation works in a form, and this does not work in playgrounds. So I had to move it into the application. So neither one of those pieces of code should actually be in the application. But I wanted to show you that, you know, when you build a form, this is what the chooser looks like. So when you go back to the form playground and you actually want to see it running, yeah, you can come back to this piece of code, but not a problem. So we have a menu here, and we just want to go to bike info, and then we just want to look at the bike stations, and this will bring up a list. This list is nothing but an array, and then we navigate to a map, and the only reason that we're able to show this map so elegantly and easily is because on iOS 14, SwiftUI has its own map. And there's certain things that SwiftUI does not have, and you have to go to UIKit to get them. So map, as of WWDC 2020, was one of them. But now in iOS 14, we have a SwiftUI map, and we're able to get the map in there without touching UIKit. And I have nothing against UIKit. I'm just, you know, saying that probably there's more things that are going to be moving from UIKit to SwiftUI as you know, we go forward, which is just a telling tale. Yes. So what's really cool is as I build up this app, and I will be building out this app, adding more features. So as you do more pull requests, you'll see more features coming on, and you'll be able to see how many bikes are actually, we know the capacity is 35, how many are actually here. I'm going to put in your calendar, so you're going to be able to see where you are right now, where your next calendar event is, and then what bike station you should go to, and then the path, your walking path from where you are to the bike station to your next calendar event. So if you watch this repo, all that's coming. It'll give you an idea. Maybe I'll even put CoreData in here just to show you how easy it is to use. But for now, I just wanted to give you like the most basic skeleton. So this is what our little bike app does. And so the first thing we had to do was get the APIs. And the APIs are actually generated under the combine. If you look under the bike shared API, you're going to see this API, and we're talking to the global bike API. So HTTPS, Ford bike, and then English. And right now we're getting the station info, but it's really easy for you to get like the system info and display that in SwiftUI. So once we make this call, right, all this should be done. Always come back to this. All of our business logic should always be done in the view model. We should not have any code in our views. Our views should be very, very thin, and our view model should have nice objects that we can test on, right? So there should be no logic in our, that's another thing why you have to think about your architecture before you write your first line of code, because you really want to think about how the system is going to come together. So we're going to go to our view model, and we're going to say, you know what? Our view model has to be observable, and it has to be identifiable, because when we go to build our navigation list, it has to be identifiable and it has to be observable so that our views update as our model changes. So we have our stations, right? And what we're going to do is we're going to go get our station information by using combine, right? So if we were to look at this, we have a, okay, we have a a station info that we call, and basically we just call that station info with the URL, and then combine will take care of the rest for us. Now, I told you whenever we start a publisher, we have to hold on to all of our cancelables. If we don't hold on to our cancelables, then the publication's dropped, right? So here we see that we are returning from the bike info the cancelable. And if we were to actually look at the where this is called, this goes into an array of cancelables that allow us to hold on. We store it, we store it in this disposables, which is an array of cancelables, right? If we didn't hold on to the subscription, if we didn't hold on to that cancelable, as soon as it was initialized, it would be dropped. Okay. Okay, so we're not losing our cancelable. This is a combined feature that allows us to go out to the web and retrieve information. Now, what we want to do is, if there's any errors, we want to go ahead and handle those. So here, we're making sure that our response from combine going out to the web to get our data for us is good data. And then we're going to go ahead and decode that good data that we got, right? So we're returning the data and we're going to actually put it into the station info. So we're going to use this JSON decoder to put the information, and this is a really, really powerful tool that knows how to read JSON. And all this, like if we were to look at the URL call, you'd realize it's just a big JSON object. We would get this JSON object and we would decode it and we put it into the system info. So this bike API, right? We're inside bike API right now. It knows how to use a URL session using the combined framework to talk to the web and return to us a publisher that is going to publish this data. Now, one of the really simple things we can do is when we go to this bike info, we could easily replace this combined framework call with something that talks to CoreData. And like I said, CoreData and combine are just, it's like a duck to water, how easy it is to make those work. Or any other type of data that we own, we can just go ahead and get the publisher from here, right? So I don't have to go out to the web. I can make this API call. I can make this API call, and I could actually take this stuff and put it into CoreData, and then out of CoreData, publish that, right? Or any other number of crazy mechanisms you can come up with to get our model. So this is our model, right? Now we want our view model to hold our model. When we get this decoded JSON, we want to have a simple way to be able to work with this model. And that's where this station info and system info Swift files come from. So what you do to get all these files, because we're not going to write any of this, any of these files, right? These are all these data structures they were all written for us. So basically, these are all just the data structures that are used to hold the data that's coming from the web. So if we look at the station info, it has information about the last time it was updated. If we look at the, we could get the ID, the rental methods, the capacity it has, its location. All these Swifts are all just data types that are generated from the JSON, query that we make, right? So all this information is what our view model needs to have so that it can update the view. We want to put all this information from the JSON. We want to take it all from the JSON object and put it and populate this. So this is super easy to do. You just go over to this site, QuickType, and you just grab the JSON that was generated from the URL call, right? So say we have the URL call. All right. We have the URL call. Fix this up real quick. So we have this URL call, and once we give it to QuickType, it will generate all of the files that you see under the shared bike API. It's going to generate all that stuff. So we should never have to type in any of that information. And this is really important because if we leave this step out, we'll be writing code for days. Sorry, I should have had this queued up. I don't know why I didn't. Really quickly, this will just take a sec. Okay, so if I just select all and then copy it and then put it in here. Okay, we're done. Boom, done. Okay, so now all the code is generated for me, right? I can basically take that JSON decoder and point it to this data class, and it will populate all of the information for me. So all I did was I said, make sure it's Swift 5, and then render 1 for each, and then I downloaded the code. So now I have all this code, right? That generated all the code for me. So in my model view, when I fetch the data, all I do is I store it inside, I populate all this information. And now I can just query it, right? It's just a data structure that I can easily and simply query. So I fetch my data, and then this populates all my stations. Thanks for the link. When I go to view my bike station info, what you'll notice is my view gets a value from my view goes ahead and gets my view model. When you want to use your view model in your view, you can decide how much of that view model, how much access it has to your data. You could use just a part of your data. You could alter your data. You could do a lot of different things with your data as you're pulling it into the view model, right? So the view model gets a chance to clean up the data as it's pulled through. And then you can have multiple view models. You can have different view models for different views, but then you use those view models to bind to your view. So here, my system started up, right? And I went out to the web and I populated all of my data, right? I populated all my data inside my view model with the information from my model. So now, if I want to show the first screen, which is the list of bikes, I just go to my view model, right? And it's an observed object because I don't own this thing. And I have a little bit of state that says, is it editable, right? Because that's not a part, that should just be local to my view. And what I can do is I can just take this list of stations and put it in the body of my view. And when I do that, right, I get a row for each station. And then if I want to do a detail, all I do is I put a navigation link to the detailed view, right? That's it. That's all I have to do. If I took this out, I wouldn't have a detailed view. I would just have my normal view of my list. But by adding one line, I get a detailed view, right? Right. So this list is coming from my view model. And then these arrows only exist because of this line. Now that I have that, I can click on this, right? And it's going to take me to this map view. Well, the map view is just, if I change this and just put text in here, like I could just put text in here. Every view works, right? So instead of going to this view, I could have the world's simplest view, which would just be text. And here, what would I like to put? Oh, here I'd like to put I think it's right, because text is a view, right? It's a full. Oh, sorry. Something. Can you fix it for me? Insert by string. I'm missing. Oh, thank you. Navigation link. Okay. So all that just to make a simple point that a text is a view. I think you guys know what I mean. Yeah. So now we want to just look at this view. It's just a view. It's a normal view. And so we're going to go look at that guy. I just want to finish making my point. So you click on this, and it just gives you the capacity, right? Because the text view is the most complex view in the world, the simplest view in the world. They're just both views. So now we're going to just go look at this view. And here, all I'm doing is I'm getting the Latin long, right? To be able to use the map in iOS 14, you have to use this call right here, make coordinate region, right? This requires a binding, right? So when I want to build my region, I need to make my own binding, right? So this only works with iOS 14. We're making a map view with just using SwiftUI. Before WWDC 2020, if you want to do this, you had to use UIKit. So this map view requires a binding, right? Now, that binding needs a Latin along, right? So how am I going to get my Latin long to this binding? Well, the only thing that a binding can take is an at state. Remember, bindings have to have their memory somewhere else. So when I passed in the Latin long for this guy, I have to send it, I have to have the memory allocated somewhere else. Now, when my bike station is sending in the information about the station, right here, we're passing in the station to the bike map view, and so we see it here. I'm not passing in the Latin long, right? And the Latin long I'm passing in are not at state, right? They're just values, right? So what I do here is I take those states, and I've kind of made this more complex so I can talk about it, right? So there's actually a lot easier way to do this, and maybe the next version of this, I'll show you how to do this a lot easier, but if I did it the easier way, I couldn't make my point. So, and this is the last point, and then we're kind of done for the day. But this is like a good explanation of how all this stuff comes together. Because this MK coordinate region must be a binding, I can't just pass down these values. I have to pass something that a binding can handle. So then I went ahead and made two new state functions. And then in my initialization, I initialized those states. Now it's kind of interesting. Before I always showed you how you had to initialize your state, but I never showed you how to do it inside of initializer. You can actually call state, and it'll generate a state, and it'll give it back to you. But you have to use the underscore because you don't want to talk to the state. You want to talk to the value of the state. So you have to put underscores under these variables. Okay, I did all that just to point that out, just to say that. Now, okay, moving forward. Now that we have these values in state, we can go ahead and we can make our binding, right? And our binding now can use those states, right? Because bindings can take states. And this binding, right, can now be used by our MK binding region. So we can get a region and we can pass that region to this coordinator, right? So option, click on this guy. This coordinator needs a binding to the MK region to be able to show you the region, right? So had to get all the types right so that I could now use this map and send in the Latin longs to be able to show the map. Okay, so this was contrived. There's a much easier way to do that, and I will code that up, but if I did it the easier way, then I can make all my points about how you would build a state yourself, right? You would build a state yourself and then add in the values and then make your own binding and then give that to the coordinate region, and then that's how you get your map. So in conclusion, right? Oh, I changed the code. Okay. So in conclusion, this guy would let me come to source code, I would discard my changes, but it's not letting me do that. Okay, so in conclusion, what I would like to do now is I'm gonna move over to the part, like if this was an under COVID, basically I would be done talking and I'd be walking through with you guys, watching you play with this stuff. So what I'm gonna do is I'm gonna stop the recording, I'm gonna stop talking, and basically if you guys wanna go to one of the other sessions or you wanna do it, I'm gonna be on Slack. I'm gonna go get lunch and come back, but I will be on Slack later and I will update the two playgrounds, and I will answer questions about how this application works. But I hope you guys get a chance to play with a map a little bit, play with the view a little bit, and hopefully I made it simple enough where you guys can come in here and play around with a little bit of this SwiftUI combined framework, and add some bindable objects and some observables and see how it's going. So with that, I'm going to sign off, and if you have questions, I'm going to get lunch, but I will be back and I will be on Slack. And I hope you guys get a chance to play with this stuff. I will be updating this code. I will be updating the collab, the playgrounds, the Slack channel. And if I give this talk again in the future, I will post it. And you guys can see how far the bike shared app has come, and more playgrounds are coming on the way. And I hope that the shared bike app is simple enough where you guys can start playing with it. So again, it starts with this little app. This little app brings up the content view. The content view brings up the navigation link. The navigation link brings up the home view. The home view brings up the bike menu. The bike menu brings up the station view. The station view brings up the map view. And with that, thank you guys.